When I first started the Astrum channel, the first planet I ever made a video on was Mars. It's easy to see why. Mars has long held a place in our collective hearts thanks to its position as one of our closest neighbours. It's a fascinating world, and sci-fi writers and scientists alike have long pondered its potential as a home for alien life. Our search for answers has caused us to explore Mars' surface with rovers and orbiters, which have taken incredible images in pristine 4K or higher resolution. Mars has a rugged beauty, a reddish hue that captures our imagination, and awe-inspiring features and landmarks to explore. What would it be like to walk on Mars' surface? What would we see? What is there to know about the red planet? I'm Alex McColgan and you're watching Astrum. Come and see some of the captivating 4K images of the planet NASA and plenty of space agencies around the world are racing to get to, as we explore some of the most incredible sides of Mars that you may not have seen before. To begin with, for an alien planet, Mars is not as foreign as you might think. Earth and Mars share a lot of similarities, one being the length of day. The solar day on Mars is only slightly longer than it is on Earth, 24 hours, 39 minutes and 35 seconds. Its year is slightly longer than ours, 1.88 Earth years, or 1 year, 320 days and 80.2 hours. But that's to be expected for a planet that's further from the Sun and so has a larger orbit. Of all the planets in the solar system, the seasons of Mars are the most Earth-like due to the similar tilts of the two planets' rotational axes, 23.5 degrees on Earth and 25 degrees on Mars. So, what does that imply? It means Mars has summers and winters just like Earth does. These temperatures in the different seasons can vary quite a lot, and different locations can widen the range even further. Temperatures can be as low as minus 143 degrees Celsius at the polar winter caps, to as high as 35 degrees Celsius in the equatorial summer. It has polar caps just like we do. During each pole's winter, the pole lies in continuous darkness just like on Earth. However, unlike on Earth, the temperature gets so cold that the atmosphere there freezes into slabs of CO2 ice, which collects on the surface of the permanent polar caps there. These caps themselves are not primarily made of CO2, but instead are made up mostly of water ice. The ice at the poles waxes and wanes. In this short video, you can actually see the differences of the size of the polar cap, from the cap's winter to the cap's summer. One thing I love about Mars are these strange spiral patterns in the ice. Both of the poles show signs of these beautiful spirals, which scientists believe are a result of the Coriolis effect. The CO2 at the poles does not remain there forever. As the CO2 ice on the poles sublimates, it has a knock-on effect on another aspect of the planet, its winds. Sublimation of dry ice can create enormous wind speeds of up to 400 km per hour, which can have a real impact on the dust strewn across Mars' surface, which we'll explore in detail later. While Mars and Earth have their similarities, there are plenty of differences too. Mars is smaller than Earth, 6,779 kilometers in diameter versus 12,742 kilometers, and it's also much less dense. This means the gravitational pull at the surface is much weaker than that on Earth. To get a feel of the impact of this reduced gravity, allow me to demonstrate with an example. As you can see, the object does fall slower on Mars than it does on Earth. This is because Mars' gravitational pull is 62% lower than what we feel here. If you weighed 100 kilograms on Earth, you'd only weigh 38 kilograms on Mars. Curiously, this is almost the same gravity as you'd experience on Mercury, even though that planet is smaller than Mars, with a diameter of only 4,879 kilometers. Mars's gravity is only stronger by 1%, which just goes to show how much denser Mercury is by comparison. This allows for some truly amazing geological features, like this one, Olympus Mons, which is the tallest volcano and second tallest mountain in the solar system, only being beaten out by Rhea Silvia Peak on the Vesta asteroid. The fact that it's not the tallest mountain, to me, is a bit of a cheat, as Rhea Silvia has the added advantage of being in the center of a large crater, and measurements of its height tend to start from the bottom of that crater. Regardless, Olympus Mons stands 3 times as tall as Mount Everest's high point above sea level. Where Everest is very jagged and steep, the edifice of Olympus Mons is over 600 kilometers wide. It rises to the equivalent of 22 kilometers above sea level, which would be impossible on Earth as Earth's gravity would pull it down. The only reason a structure like this is standing on Mars is because its gravity is reasonably weak. Olympus Mons is a shield volcano and thus has a very low profile. The average slope is only 5 degrees, which means if you were to stand on the top, you wouldn't be able to see the entire mountain due to the curvature of the planet. Olympus Mons can easily be seen from space. If we look at the topographic map, you can see it quite clearly. To me, this really does look like a giant pimple on the side of the planet. The center of the volcano has some collapsed craters, as you can see, and the outline of the volcano is this giant cliff face, which is up to 8 kilometers high. Another impressive feature of Mars stretches across the side of the planet like a giant scar. It's called Valles Marineris, and every time I look at it, I can't help but be amazed by the sheer scale of it. This giant canyon is 3 times the length of Earth's Grand Canyon and 4 times as deep. But when you look at the planet Mars, one of its most recognizable features is its color. Why is the surface of Mars so red? It all comes down to the large quantities of iron in Mars's surface. Over time, these minerals have reacted with oxygen to create iron oxide, or to put it another way, the planet has slowly rusted, just as iron does here on Earth in certain conditions. This explains the ground and rocks' reddish-brown hue, as you can see in these photos taken by the various NASA rovers on Mars over the years. Images like these really help you feel like you're there on the planet's surface, in a level of resolution and clarity that would have been an impossible pipe dream for astronomers only a century ago. Thanks to missions like Viking 1 and 2, Spirit, Opportunity, and Perseverance, we can see Mars's arid vistas as if they were right before us. Now, after looking at some of these pictures, you might be tempted to think that the red planet is a dead planet, but actually that's far from the case. Mars is very active, and there's lots of things happening on its surface. For example, have a look at this avalanche which happened in 2008 as an orbiter was going past. What was caught on camera was very surprising. Scientists could see a lot of dust had been kicked up by the fallen dirt. What you're looking at here are some dunes which are up to 700 meters tall, and this picture is about 4 miles wide, so you can see that the dust cloud is not exactly small. And here, take a look at this. Did you know that there are spider colonies on Mars? Arachnophobes? Don't worry. These creepy crawly shapes might be 45 meters to 1 kilometer across, but they are not truly spiders. Instead, they are carbon dioxide ice that has been warmed up by spring sunshine. Ice underneath the surface is warmed by sunlight and reverts back into its gaseous form, which then bursts through the ice up to 1 meter thick on its way back to the Martian atmosphere. This eruption of gas explodes upward in a large geyser and takes dark material with it, scattering the material around in spider-like patterns. These images were taken by the ESA ExoMars Trace Gas Orbiter just recently, as it flew over Mars in early 2024. Another example is this dune, photographed many times over the course of a year, and you can see that it does change quite a lot. There are ridges which become more apparent as the dust gets worn away. And I've shown a number of pictures of fresh impact craters so far, where you can see the dust has been kicked up by the impact. This one is particularly interesting because after the impact, water ice in the ground melted, and you can see the trail as it flowed away from the impact crater. The colours there are just to show depth, they're not real colours. Mars' surface is awe-inspiring to look at, but this is sometimes harder to do than you might think, as Mars is home to huge dust storms. When fast winds pass over the surface, they pick up a lot of the loose dust on the ground, creating huge walls which can pass over the whole planet. It's sometimes hard to imagine the scale of the phenomena. These storms can very easily be seen from space. Have a look at this dust storm, which was captured in 2012, and then only a week later you can see the difference since it died down. And on this photo, if you look at the North Pole, you'll see the storm which has passed over the top. Global dust storms are unlike anything we ever experience here on Earth, and they are so fascinating. I've done a whole video on them, which you can watch here. What do you think caused these patterns on the surface of Mars? Amazingly, they're caused by dust devils. These mini tornadoes are surprisingly common on Mars and have been photographed many times. Here we can see some from the orbiter's point of view. It's estimated that this plume is over 800 meters high and about 30 meters thick, and the shadow of this dust devil is about 2 kilometers across. And from the rover's perspective, we're actually fortunate enough to have a film of dust devils going past. You might think that with all the atmospheric phenomena we've just discussed, that Mars has an atmosphere that's comparable to that on Earth. This is not the case at all. We are 38,000 feet in the air right now above the ground level, and the air here is very, very thin. If I was to go out of the bay right now, not only would I fall to my death, but I would also struggle to breathe along the way. Now, Mars is a bit like this, except even worse. If I wanted to actually get the same sort of atmosphere pressure as Mars, I'd need to go up to 120,000 feet into the Earth's atmosphere to get a similar sort of level. The breathing issue isn't helped either by the fact that 96% of the atmosphere is carbon dioxide. So, if you did want to visit Mars, you'd have to wear a pressure suit. Thankfully though, that doesn't stop Mars from having some absolutely beautiful sunsets, some of which have actually been captured by the rovers on Mars. The lower atmospheric pressure on Mars wasn't always that way. The presence of dry riverbeds proves that Mars's atmosphere was once thick enough to retain the heat and pressure necessary for liquid water to flow. So where did that atmosphere go? Scientists believe that Mars's magnetosphere, or lack of one, is to blame. Scientists believe that Mars lost its magnetosphere 4 billion years ago, which allowed solar winds to strip away atoms from the upper atmosphere for all of that time. Some orbiters of Mars have actually detected these ionized atmospheric particles trailing off into space behind Mars. One of the last things I want to focus on today is Mars's moons. Mars has 2 known moons, Phobos and Deimos, which are small and irregularly shaped. Compared to our own moon, they are very small. If you were to look up into the sky on Mars, this is about how big they would be in comparison to what the moon looks like in our sky. While Phobos is the biggest of Mars's moons, even here its apparent size is a little misleading, as Phobos is actually a lot closer to Mars than Earth's moon is to Earth. The moon is 384,400 kilometers from us. Phobos is just 6,000 kilometers from Mars, a little further away than London is to New York. It might be more surprising to you that the moon is so far away from us. You can fit several Earths between the Earth and the Moon, but only one Mars between Mars and Phobos. Deimos, on the other hand, is very small and also very far away. So while Phobos is relatively large in Mars' night sky, Deimos looks like just a star orbiting the planet. I think you'll agree though, they are very pretty moons, even if they are tiny. And I'm not done with them just yet. I want to show you something I found absolutely amazing the first time I saw it. It's a solar eclipse of Phobos as taken from one of the rovers on Mars. Now, I've barely seen a solar eclipse while I've been on Earth, so to see one on Mars, that's just something else. You can see Phobos in all of its irregular glory as it passes by the sun. It's interesting to see the effect it has on the lighting in the area too. Everything goes a bit darker as it goes past. Finding answers to the great questions on Mars can be difficult, but on Earth, data brokers collect your answers and then sell that information on to whoever wants to buy it. This is done without your knowledge or consent. It is all done legally. They have to remove your info if you ask them, but they make it incredibly difficult to do. Fortunately, I was able to turn to the sponsor of today's video, Aura. Aura tackles data brokers on your behalf and forces them to take down your stored personal data. But they also do so much more. Aura is a VPN and an antivirus software, an ad blocker, a password manager. It's a safe vault for your files. It scans the dark web to give you early warning of data leaks. It blew my mind how comprehensive Aura is. It really is all-in-one digital security. So if you want to feel completely covered digitally, why not give Aura a try? Scan my QR code or follow my link aura.com/Astrum Extra, which you can also find in the description below for a 14-day free trial. See if you're as impressed as I am. By the end of the next decade, the first human feet will likely touch down on the dusty red soil of Mars. This is NASA's timeline, and it is by no means unrealistic. And while that first visit might be similar to a stop by in line with the moon landing, some scientists are claiming permanent human colonies could be set up on Mars as early as 2050. That means it could be you, alive today and watching this video, who is the one who sets out to tame that new frontier. You'd need to get into a space program pretty sharply if you're not in one already, but it is possible that you'll one day look out of a little bay window and watch as our pale blue dot vanishes into distant space. But as you turn your gaze to your new home, what conditions can you expect to find on Mars? What challenges face any would-be Martian colonizer? What deadly weather will you encounter? What will the red planet throw at you? For, unlike our home planet, Mars is a dead world, and anyone hoping to set foot there will need to overcome its daunting challenges with technology that is at the very cutting edge. I'm Alex McColgan and you're watching Astrum. Join me and a very special guest today in this supercut on the environment of Mars, as we explain both the hostile conditions and exactly what NASA is developing to help future Martians like you to tame those arid, rusted wastelands. And stick around till the end of the video for a very special announcement. You don't want to miss it. Obviously, to colonize Mars, you first have to get there. The trip itself to Mars would take about 3 months with the most optimal launch conditions. This doesn't seem too excessive. It's like a long voyage on a cruise ship. But you have to consider that you would spend at least 3 months outside the safety of Earth's magnetic field. Out here, you are exposed to the solar wind and cosmic radiation. Prolonged exposure to this kind of radiation can cause astronauts to develop cancer and even symptoms of Alzheimer's before they reach Mars. Fortunately, there are some thoughts about how to protect against this. The astronauts could be shielded using materials in the ship's construction that are rich in hydrogen. In fact, the cabin could be surrounded by a water tank in the walls, water being rich in hydrogen. Another option is to create a magnetic field around the spacecraft.
but this requires generating a huge amount of energy from a reactor small enough to fit on the ship, something we don't have the technology to do safely just yet.
Once there, for an alien planet, Mars is not as foreign as you might think. Earth and Mars share a lot of similarities, one being the length of day. The solar day on Mars is only slightly longer than it is on Earth, 24 hours, 39 minutes and 35 seconds. Its year is slightly longer than ours, 1.88 Earth years, or 1 year, 320 days and 80.2 hours. But that's to be expected for a planet that's further from the Sun and so has a larger orbit. Of all the planets in the solar system, the seasons of Mars are the most Earth-like due to the similar tilts of the two planets' rotational axes, 23.5 degrees on Earth and 25 degrees on Mars. So, what does that imply? It means Mars has summers and winters just like Earth does. These temperatures in the different seasons can vary quite a lot, and different locations can widen the range even further. Temperatures can be as low as minus 143 degrees Celsius at the polar winter caps to as high as 35 degrees Celsius in the equatorial summer. It has polar caps just like we do. During each pole's winter, the pole lies in continuous darkness just like on Earth. However, unlike on Earth, the temperature gets so cold that the atmosphere there freezes into slabs of CO2 ice, which collects on the surface of the permanent polar caps there. These caps themselves are not primarily made of CO2, but instead are made up mostly of water ice. The ice at the poles waxes and wanes. In this short video, you can actually see the differences of the size of the polar cap, from the cap's winter to the cap's summer. One thing I love about Mars are these strange spiral patterns in the ice. Both of the poles show signs of these beautiful spirals, which scientists believe are a result of the Coriolis effect. The CO2 at the poles does not remain there forever. As the CO2 ice on the poles sublimates, it has a knock-on effect on another aspect of the planet, its winds. Sublimation of dry ice can create enormous wind speeds, which causes one of the most unique and terrifying aspects of Martian weather, its dust storms. If you peered across the rusted Martian surface through photos, you would be forgiven for thinking that Mars is a place of stillness. Flat, dusty landscapes seem to stretch out in all directions, with nothing but scatterings of rock and the faint whistling of the wind to keep at bay the almost oppressive solitude. But stay a while on this red world, and you would soon see a towering wall of dust and sand brewing on the horizon. You might think to yourself that this dust storm is similar to those we see on Earth, and have no idea that this storm is about to grow so large its thick dust will swallow up not just a region, not just a continent, but the entire planet. This all-enveloping superstorm arises on Mars usually every 3 Martian years, or about 5.5 Earth years. Its choking dust will blot out light for weeks, even months, and represents a huge challenge to the continued functionality of any technology that we put up there. If humans ever want to settle down on the red planet, it will be a hurdle we have to overcome. Which is a problem, as there is much about the origins of these storms that we still don't know. Mars didn't used to have to deal with planet-sized dust storms. Although Mars is now a barren, arid planet, it once had a thick atmosphere that was warm enough to support the existence of running water. However, over the course of the billions of years of Mars's existence, Mars dried out, and its atmosphere bled away until atmospheric volume was at less than 1% of what we have here on Earth. Those dust storms didn't just start happening because Mars became dry though. Although we don't understand everything about such storms' origins, we assume that a key component is Mars's temperature. With less atmosphere, in spite of Mars's high CO2 levels, Mars became far worse at retaining heat. When the surface starts to cool, there is no air to catch the escaping warmth. It is at the point where, If you were to stand on the planet's equator during its warmest time of the day, your feet might feel 23 degrees Celsius, while at your head, it would be 0 degrees Celsius. As mentioned earlier, this means between day and night, Mars has some intense temperature swings. Temperature differences can cause winds to form, which can bring different weather systems across the planet. However, Mars's arid weather is no longer driven by rain and water cycles, but cycles of dust. Dust plays a surprisingly crucial role on Mars, and without it, those planet-spanning storms would likely never form. The atmosphere might be too thin to capture and transport heat, but the Martian dust, now that's another story. It all begins with that Martian dust getting into the air. There are a few mechanisms that make this happen. One is dust devils, of which Mars experiences thousands every year, usually during the Martian spring and summer. Warm rays from the sun heat the ground, causing the air directly next to it to rise, and cool air from the atmosphere to be drawn down to fill the vacuum. These contrasting winds create rising spirals of air that can end up hundreds of meters wide and 8.5 kilometers tall, although many are much smaller. Regardless of their size, as they meander their way across Mars's all-encompassing deserts, they suck up dust and hurl it up into the atmosphere, creating a haze of slightly darkened skies in their wake. This process is thought to contribute to a miasma of background dust that constantly lingers in Mars's atmosphere. While this is the flashiest way by which dust gets into the atmosphere, it's not the most prevalent. Far more common is the simple influence of wind moving across Mars's dusty surface, and a process known as saltation. Mars's dust is surprisingly difficult to get up into the air. Small particles have a lot of cohesion due to being slightly electrostatic, kind of like packing peanuts, so that they stick together, which means they need a certain amount of momentum to get them going. Oddly enough, larger particles are actually easier for the wind to get moving as they experience less cohesion. So, it's these larger sand grains that are lifted by gusts of wind and are moved for short distances. But because they are ultimately too heavy for the wind to suspend, they crash down again, and the force of these tiny impacts imparts enough momentum to overcome cohesion and get the lighter dust airborne. However, once it gets up there, Mars's lower gravity means that it's easy for dust to remain in Mars's atmosphere for a really long time, weeks or months. And this is enough to start driving the formation of storms. Because, unlike the thin air around them, particles of dust are really good at collecting heat from the sun. As the sun warms dust in the atmosphere, they act like little radiators, slowly releasing the gathered heat into the air around them where previously the warmth would have passed through the ground below. This makes the atmosphere nearby much warmer. Warm air rises, but now it begins doing so on a much larger scale than when forming the dust devils earlier. Wind has to be drawn in from the sides of the rising air mass, but this only adds more fuel to the fire. More wind means more saltation, and more dust being thrown into the atmosphere, and more opportunity for the atmosphere to warm. Eventually, this out-of-control process ramps up into a regional dust storm. The good news is that on a local scale, a dust storm on Mars is not very dangerous in and of itself. Wind speeds top out at 97 kilometers an hour, only half the speed of hurricane winds on Earth. And even this is misleading due to the thinness of the atmosphere. Even when it is traveling quickly, you wouldn't feel much. In the same way, a single person has less pushing power than a whole crowd. Despite what you might see in some science fiction stories based on Mars, dust storms are not powerful enough to push over spacecraft or break satellite dishes. But that is not to say they can't cause problems. Consider the case of NASA's Opportunity rover. On the 28th of June 2007, or 1,200 sols into the mission, Opportunity prepared itself for its descent into Victoria Crater. But just as it perched itself on top of the slope,
the biggest dust storm opportunity had seen yet rolled in, decreasing the brightness of the sun by 96%. That's not quite as bad as it sounds, as the dust also scattered some of the sunlight towards the rover too, meaning it was generating 128 watts on the darkest day compared to its usual 700 watts on a clear day. But this is bad news for a solar-powered rover. That kind of power level isn't enough to keep the rover going. In fact, anything under 150 watts means the batteries begin to run flat. So operations were cut back substantially until the storm was over. An opportunity was commanded to only communicate back to Earth once every 3 days. If the batteries did run flat, the components on board Opportunity could be damaged due to the intense cold on the planet during the night. Typically, the motors have heaters powered by the batteries during the night to keep the motors warm. If the batteries run flat, there would be nothing to stop there being extreme temperature differences between the night and day. At the equator, anything up to 20 degrees Celsius during the day and minus 75 degrees Celsius at its coldest at night, which would damage the sensitive components. As for the dust storm, mission controllers initially thought it would only last a week, but by the 15th of July, the storm had reached its peak. These are true color images showing a time-lapse of the storm, and as you can see, it does get very dark. Thankfully, the severity of the dust storm was not quite enough to trigger the low power fault this time, although it did get worryingly close for a while. Eventually, by the 21st of August, or Sol 1271, the storm had cleared enough so that Opportunity could start to move forward again. A lucky turn of events for Opportunity, but not all rovers on Mars are so lucky. At the end of that same year, the Spirit rover was facing serious problems. Martian storms had been increasing in recent months, leaving the solar panels heavily covered with dust, as well as blocking up to 99% of the light through the atmosphere. Survival was becoming harder, and operations were now much reduced from its peak. The aging Spirit was generating only 128 watt-hours, which is less than the 150 it requires to keep itself warm. As mentioned, if the heating fails, then the rover's components will eventually fail too. 2 small cleaning events took the energy output of the solar arrays to 372. This gave the rover enough energy to charge its batteries and begin to move again. But the flow of time is always cruel. Spirit began to experience unexplained memory gaps in April 2009, with the rover now only 4 meters away from its resting place. On Sol 1892, Spirit hit incredibly soft, dusty soil at a location named Troy, where Spirit would make its last stand. Underneath its wheels was jarosite, which is a mineral of iron sulfate. Jarosite has remarkably low cohesion, meaning that achieving enough traction to move was proving impossible. Despite efforts by the JPL back on Earth to explore techniques to escape the sand trap, no progress was made. On Sol 2155, NASA reclassified the mission as a stationary research platform. While there, our rover took measurements of the atmosphere and several more images, including its last panorama from Troy. Spirit was still able to perform soil studies and extraction tests because the functionality of its arm was still excellent. Spirit needed to have a busy research schedule to use the power it was generating to maintain good battery health. But the final winter was approaching for Spirit, and it was a bitter one. Over the next few months, the power generation continually dropped, and by Sol 2196, it was again down to the critical 150 watt-hours. Sometime on Sol 2208, it is believed Spirit suffered a low power fault. The Spirit rover went quiet for good. So, it's very bad news for any Martian rover that relies on solar power to function if a dust storm filled with slightly sticky electrostatic dust particles suddenly passes overhead. Gradually, dust deposited from such storms is enough to block sunlight from reaching a rover's solar panels, which has spelled the end of more than one mission from Earth. But the problems magnify when you start scaling such storms to larger and larger sizes. Mars does not have a perfectly circular orbit. Every year, around the Martian southern hemisphere's spring and summer, the planet is at its closest to the Sun and, as a whole, is warmest. For reasons we don't fully understand, during this time of year, regional dust storms start merging into a superstorm the size of a continent. It's of course possible that several storms just happened to be forming anyway and they started to merge just by proximity. Although their regularity makes it seem like coincidence is insufficient an explanation. After all, these happen yearly, like clockwork, once the temperature gets warm enough. Those are just the continent-sized ones. Scientists of yet do not have an explanation for the stage above that, the planet-sized storms. These occur once every 3 Martian years, which seems like a short enough timescale that you can rule out Milankovitch cycles as their origin. Those normally work on timescales of thousands to hundreds of thousands of years. Perhaps there is some aspect to the dust cycle that needs to restock, and it takes 3 Martian years, or around 5.5 Earth ones, to do so. We don't really know. While most dust storms on Mars last only a few days, these apex of storms can last for weeks. The impact of these storms can be profound for any human technology around the planet. Scientists can measure the availability of sunlight on Mars using aerosol optical depth, or AOD, to check how much sunlight is being absorbed or reflected by pollutants in the air. The AOD on Mars is usually around 0.5. For context, an AOD of less than 2 is needed before rovers like Opportunity or landers like InSight can charge their onboard batteries. The thick smoke caused by a wildfire on Earth that starts to turn day into night is an AOD of 7. These planet-sized dust storms hit AOD of 9 to 11. They represent a near total blockage of light. In 2018, a storm of this variety killed the Opportunity rover by swamping its solar panels and forcing it into hibernation mode. Without power running through its onboard heaters, the wildly oscillating day-night temperatures caused something critical to break in the rover, and it never woke up. These storms are a problem for other rovers too, even ones with onboard nuclear batteries like Curiosity. The clouds are thick enough to block communication to and from the surface, meaning scientists have little choice but to wait them out. But that's not all. Even satellites can be affected by these storms. The colossal amounts of warming dust in the air causes the entire atmosphere to expand, bringing some of it into the orbital paths of satellites. They have to burn precious fuel, making course corrections to ensure the atmospheric drag doesn't bring them crashing down out of the Martian sky. If you were a human hoping to settle on Mars, you'd need to find a way to overcome these issues. Solar-powered settlements would not survive such storms without another source of power, and humans don't do well at such freezing temperatures. Losing the ability to contact our satellites could also leave us isolated and vulnerable for those few weeks. People would need to have a certain degree of self-sufficiency, as if anything were to go wrong while a storm was blowing, you wouldn't be able to call for help. Still, in time, these storms prove to be their own destruction. Blocking so much light eventually means that the surface stops getting warmed enough to create the upswelling winds that lifts the dust into the air in the first place. Without more rising dust, these storms starve themselves and peter out. Do you want to know what the wind on Mars sounds like? You don't have to imagine it. In 2018, the InSight lander recorded the sound of Mars's wind using its onboard seismometer, which had not yet been deployed to the ground to detect Marsquake vibrations. This is what it sounds like, although I should note that you will probably either need a subwoofer or headphones to hear this. This has not been sped up. These literally are the vibrations caused by Martian wind going over the solar panels of the lander. The frequency of the vibrations converted to audio. What is fascinating is that we don't just have to imagine the wind passing by InSight, as it was also able to capture footage of water ice clouds passing by overhead, visibly showing the direction of the wind. Yes, although Mars is currently a barren wasteland, there is still a tiny amount of water vapor in the atmosphere. Overall, the atmosphere and weather on Mars remains inhospitable. But what of its soil? Many of us have seen The Martian. In my opinion, a great film about surviving on the Martian surface. One part of the film focused on growing potatoes using Martian soil. But how practical is that in reality? Does Martian soil really have the nutrients needed for plants to grow? And would there be any adverse side effects from eating produce grown on Mars? As it turns out, Martian soil does in fact have a lot of the essential nutrients needed for plants to grow, depending on where exactly you are on Mars. Just like Earth, with some areas that have nutrient-poor soil and some with nutrient-rich soil, some parts of Mars would be better suited for growing plants than others. However, the soil on Mars is more like regolith. It hasn't had a history of worms, insect and plants mixed in. In 2016, researchers grew tomato, rye, radish, pea, leek, spinach, garden rocket, cress, quinoa, and chives in an imitation Martian soil on Earth, producing only slightly less produce than they would have in Earth's soil. Interestingly, they did the same experiment again with imitation moon soil, which produced about half the amount of produce. Yet these crops still grew, with only spinach really struggling to perform. However, it should be noted that organic matter was added to the soil. In this experiment, cut up grass to fertilize the soil and fluff it up, allowing water to pass through the soil to the roots. Without that, the plants wouldn't have lasted long. Another barrier scientists would have to get through is the abundance of heavy metals, and importantly, something called calcium perchlorate in the Martian soil. Calcium perchlorate is a salt which, like heavy metals, is toxic if consumed in large quantities. This perchlorate and metals in the soil would be absorbed into the plants. Not so great for the plants anyway, but humans would then also absorb it into their system when they eat the plants. But perchlorate isn't all bad. In fact, it could help humans survive on Mars. For one thing, it sucks water out of the air, which can then be used as liquid water, which is critical for survival on Mars. It can also give off oxygen. Again, another critical checkbox for survival ticked. So in short, it seems there are two major problems to be overcome when growing plants on Mars. The first is the need for fertilizer. Going back to the film and book, The Martian, Watney overcame this problem by using feces from the toilet as fertilizer. Typically, this is dangerous as feces contains pathogens. However, if the feces have been processed to kill the pathogens, it can then safely be used as fertilizer. Once production gets underway, you could always use the compost collected from old plants and food. The second problem is the toxic perchlorates. Well, this has a simpler solution than you may think. Running water through the soil would rinse the perchlorates out, and you could then separate the water and perchlorates later so nothing is wasted. The alternative is to use perchlorate-eating bacteria, which give off oxygen as a byproduct. There is a reason why growing plants in future colonization efforts is so important. Not only does it make the colony self-sufficient, but there is also evidence that fresh foods, such as tomatoes, blueberries, and red lettuce, are a good source of antioxidants. Having fresh food like these available in space could have a positive impact on people's moods and could also provide some protection against radiation in space. So, it is possible to grow plants in Martian soil, provided you could get the fertilizer right. And adapting to Mars's unique environments is the name of the game when it comes to colonization. NASA and other space agencies are utilizing many different technologies to adapt to the specific environments on Mars. But rather than explain it all myself, why don't I hand over to our special guest from Veritasium to introduce one of those ways. Derek?
Thanks, Alex. The atmosphere on Mars is really thin, so for a long time, flying there was thought to be impossible. But we've been working with NASA's Jet Propulsion Laboratory to get exclusive access to Ingenuity, the first helicopter on Mars. Ingenuity made use of super lightweight materials and 2 sets of carbon fiber blades to achieve a total of 72 groundbreaking flights over the course of her 3-year lifespan. She traveled over 17 kilometers and took some really cool shots along the way. It's a great example of how engineers adjust their tech to the environment.
Thanks, Derek. Over on his channel, Veritasium, Derek has done an incredible video on the Ingenuity helicopter.
This will be the first powered flight in another planet.
So if you want to know more about this groundbreaking mission, you should really head over there and give it a watch. Helicopters are not the only technology they're developing at JPL for Mars exploration though. One other really cool design is something being developed in collaboration with Boston Dynamics. Exploration robots that can walk.
If you've been keeping up with the sort of robots that scientists have been sending to Mars, you will notice that they all have a fairly similar design. Spirit, Opportunity, Curiosity, Perseverance, even the Chuorong rover deployed on Mars by China are 6-wheeled rovers with large bodies, some over 2 meters tall, carrying various kinds of scientific equipment and cameras. This is because form follows function. Wheels are an easy way to help a robot to get around on a flat surface, and a large body allows for more scientific equipment to be carried. However, wheels also come with downsides, in that they limit the kinds of places these robots can explore. Remember, Spirit's mission suffered a serious setback in 2009 when it got stuck in soft sand, a trap it never escaped from. Although scientists wanted to continue using it as a stationary platform to study the area immediately around it, getting stuck was essentially the end of the mission for Spirit, especially when it drained its batteries trying to get out. And a similar thing happened to Opportunity in 2005, although fortunately in its case Opportunity was able to escape from wheel spinning after just over a month of being stuck. However, there was also a point in the first year of Opportunity's mission where it was exploring Endurance Crater. The exposed rock in the sides of this crater were ideal for answering questions about the history of water on Mars. Opportunity had limits on how steep a surface it could drive on, about 30 degrees, and it was uncertain whether it could get out of the crater again if it drove into it. In the end, scientists decided to send Opportunity into the crater anyway. As it happened, Opportunity was able to drive out and continued exploring Mars's surface for another 15 years. But all that science wouldn't have been possible if Opportunity's wheels had meant it couldn't escape endurance. Now compare that with this. This robot, known as Big Dog, was created by robotics company Boston Dynamics, a company that makes some truly impressive robots. You should check out their parkour robot, Atlas, a humanoid robot capable of running, jumping, and climbing over obstacles in a way that almost feels human. And you can really see the advantages that legs can offer in these kind of situations. Big Dog could easily traverse powdery conditions, even up slopes, allowing it to explore a greater range of areas in an environment like Mars. However, it was a later version that caught NASA's eye. Meet Spot. Spot is a walking robot originally designed for tasks on Earth, such as data collection and mapping spaces for industry, or going into dangerous areas that humans can't enter, such as in areas that are heavily irradiated. It's able to carry weights of up to 14 kilograms and can perform repetitive tasks and walk upstairs, over gravel and other uneven surfaces. It comes with cameras that can see all around it, mapping the space. If it falls over, it can self-right itself even from being completely upside down. Unlike the rovers on Mars, which have top speeds of about 0.2 kilometers per hour, Spot can travel at around 5.8 kilometers per hour. But the cleverest part about it is its intelligent AI. By using information it sees in its cameras, Spot is able to create a 3D image in its onboard computer, and it can use that information to figure out the best way to travel over obstacles. You don't necessarily control it,
Instead, you tell it where you want to go, and it figures out for itself the best way to get there, actively avoiding obstacles if they present themselves. If it does start to fall, it can figure out what it needs to do to stop falling, and moves its legs to arrest its fall in a way that almost feels alive. It is this autonomy, mixed with Spot's incredible range of versatility and movement, that makes it ideal for exploration of other planets. It's not possible to directly control a robot on another planet. The distance is so great that there would be several minute lags between a scientist sending a signal and the robot taking an action. So a lot of decision making needs to be done by a robot on location. This is true of the rovers NASA has sent to Mars already, like Spirit and Opportunity. However, Spot can take this to another level. Thanks to a collaboration with NASA's Jet Propulsion Laboratory, Spot is proving to be capable of working with a series of other robots to explore Martian analog caves here on Earth, completely independent of humans. They are exploring the whole layout on their own, choosing their path, walking over obstacles. They can handle pitch black lighting conditions, smoke, dust, and even water. They can recognize points of interest and investigate them. One area of Mars and the Moon that NASA would like to explore in future are caves. Caves are scientifically interesting for several reasons. They allow scientists to see deep into the geology of a planet without needing to do any drilling, which is a difficult process, helping them tell what the structure is like or whether water was ever present. They are sheltered ecosystems. While things on the surface might be eroded over time by wind or cosmic radiation, caves offer shelter, preserving anything scientifically interesting for us to find. NASA's Braille program is even interested in whether any bacteria might have survived in such an environment on Mars, or at least if the remains might be there. Finally, this shelter and protection from radiation also make them a good location for future human colonization, making it all the more important for us to map them out for any future human missions. Currently, we struggle to explore caves on other planets. Taking photos from space only really tells us information about maybe the entryway. Scientists can't map cave structures from orbit. Rovers like Opportunity would struggle to explore such a cave, as the ground would probably not be very flat. The passageway might become too narrow for a 2-meter wide robot, and the terrain would be uncertain. And perhaps worst of all, signal to Earth would quickly become blocked by all that rock, meaning a robot that requires any human input would not get very far. In other words, a robot that was sent to explore a cave on Mars would need to be able to go in and explore the entire thing on its own, with no prior knowledge of what the terrain might look like in there. It would need to see and map the terrain, decide how to move around it, and finally bring that information back out to the surface. And this is what NASA's Jet Propulsion Laboratory and Boston Dynamics are currently doing. By combining Nebula, an advanced decision-making AI, with the versatile platformer Spot, NASA is hoping to one day be able to send several of these robots to a cave on Mars or the Moon and have them go in and map it, independently organizing themselves by working as a group, using cameras, robotic arms, and scientific equipment to identify objects of scientific interest, relaying that information to each other, and then sending in the robot carrying the right equipment to further study and photograph the object of interest. There is currently no set date when Spot would be ready to explore the Moon or Mars. This is still in the testing phase. However, this technology offers a tantalizing possibility. One day, robotic dogs, or things like it, might form the backbone of exploration, or even labor and construction on Mars. Future humans on Mars would need to be self-sufficient. It's not like they would be able to call for help from home. We take it for granted that on Earth, if you phone someone on the other side of the planet, you might only get a split-second time delay. At these distances, the speed of light is incredibly fast. With astronomical distances, it's pretty slow. On Mars itself, the distance to Earth means the transmissions will be delayed by anything between 3 to 22 minutes. This is only one way, so accounting for the return transmission, the minimum delay is 6 minutes, making a normal phone conversation highly impractical. Text, audio, and video messages are possible, but Martian settlers will have to fend for themselves if they need to make any immediate decisions. for example in cases of emergencies or equipment failures, making remote operations or assistance in real time unfeasible. But let's say all these difficulties are overcome and that the colonists reach Mars. Where would they settle? At the moment, there is no one favourite candidate. The North Pole is a distinct possibility due to the presence of water ice in the caps there. Another interesting option is the 81 km wide Korolev crater, as it's also filled with water ice. The atmosphere isn't thick enough for liquid water to pool on the surface of Mars for any lengthy period of time. However, pockets of water locked up in ice can be found at the bottom of craters where it is cold enough. On Mars, there is also the possibility of settling near underground water deposits found in permafrost under the crust. Studies based on data from a combination of Mars orbiters have revealed and mapped out locations for water under the ground all across the planet. Although more difficult to extract than surface ice, it could open the door to colonies in more equatorial latitudes, regions that are much warmer, where solar panels for energy production would be much more effective. Mission planners would probably try to combine this finding with a location in the northern hemisphere. The ground elevation there is much lower, meaning the atmosphere is thicker, perfect for slowing and landing a spacecraft. As mentioned, another consideration when looking for a settlement location is to see if there are lava tubes nearby. A lava tube is basically a long cave that formed when magma flowed through it, that has since emptied, resulting in fairly uniform tunnels. We see many examples of these on Earth, and on Mars they could even be large enough to house buildings inside. While lava tubes and caves have been identified on Mars, suitable candidates will also need to consider what we mentioned before, the elevation of the location and the prospects of nearby water. Once a site has been chosen, missions can begin to make the area suitable for a human habitat. Not everything colonists could possibly need would fit in one spaceship to Mars, so several Forerunner missions will have to take place, laying the foundations autonomously for what the colonists will need. There have been several architectural competitions to find the best design for long-lasting habitats, although there is no model that is said to be definitive yet. There are a wide variety of proposals, from creating habitats using ice to habitats built with the design structure of fungi. However, the majority of the suggestions utilize the regolith found all over the surface of Mars to build a habitat using 3D printing techniques through autonomous robots. Unfortunately, robots like these don't exist yet, so they have to be developed before this idea even becomes a possibility. But basically, this concept requires excavating material from the surface, which would then be processed and mixed with water ice into something similar to concrete. The structure is then 3D printed layer by layer by the autonomous robots. Robotic assistance and artificial intelligence will be invaluable in preparing the habitat for the colonists' arrival. Doing it by hand once they are there would be an impossible task, since astronauts are confined to their suits, especially things requiring hard and prolonged manual labor. Once the 3D printed habitat is complete, it needs to support the weight of additional regolith. These habitats must efficiently protect the inhabitants from radiation, so in the final phase of many of these proposals, they recommend covering the habitat with more regolith simply by shoveling it on top. This is because Mars does not have a magnetic field like Earth, so radiation is a big problem on the surface too. So, the more material there is between the Sun and the colonists, the better they will be protected from its harsh radiation. Once the habitats are suitably prepared for humans, the colonists can begin to arrive. Even with the help of the autonomous robots, they still have a lot to do. Connect up power, set up equipment, just generally get the site up and running. While this is going on, they probably have to reside in temporary habitats, be it their own ship that they arrived with, or maybe inflatable habitats. In any case, these habitats would not be very spacious and only provide the basics for survival. When the permanent habitats are ready, they will need to be pressurized. One method for creating breathable air is acquiring oxygen through electrolysis, and then mix it with nitrogen. Electrolysis has the added benefit of generating hydrogen, which can then be refined into hydrazine as fuel. Once generated, this pressurized environment can easily be sustained through air recycling systems, something that is already being used by the International Space Station. Another method to get oxygen is from the carbon dioxide already in the atmosphere. That's why the Perseverance rover also incorporates the MOXIE module, which is an experiment to see if this is possible. However, for these tasks, substantial energy production is needed. One obvious source of energy is solar panels. On Mars, however, solar production is only about 40% of what you would get with the same solar panels on Earth, because Mars is further away from the Sun and receives less light. So, it's a source that is helpful only half the time due to the day and night cycle,
not to mention the sandstorms we talked about earlier.
So, this by itself isn't reliable enough for a colony. Another option is to send a not yet invented cold nuclear reactor, which will guarantee a more stable energy source. Obviously, the best solution incorporates a hybrid of both, combined with reliable batteries to store power in the event of power outages or emergencies. The settlers would also need to consider the need to produce and purify water for consumption and other purposes. Ideally, they will be able to generate 5 litres per settler per day. This shouldn't be too much of a problem, because we know where to find water already on Mars in the form of water ice. Additionally, the colonies should also incorporate water recycling systems to minimize water waste. This technology, again, is already used effectively on the International Space Station. The production of water is as simple as extracting the ice, cooking it in an oven until it evaporates, condensing it in water, and filtering it again using ceramic and carbon filters. With these steps combined, we have all the ingredients necessary to create a habitat suitable for life, an enclosed, protected environment with a steady production of oxygen and water.
With the addition of grown food, which we talked about earlier,
the colony would be self-sufficient. Although it would not be an easy life, confined to a small space, stuck with the same people, often eating the same things, and with constant tasks and stress. The psychological demands would be very taxing. Even on Earth, we have some very remote and lonely places where people live, for instance scientists in Antarctica or submarine crews. These groups undergo regular psychological checks to protect their mental health, and even in these situations, people there know that they can always be sent back home. But colonists on Mars are trapped. There's no immediate turning back, if ever, so only individuals with a strong mental fortitude could persevere. In addition, there is an array of health problems associated with low gravity. The zero gravity experiment with the Kelly twins on the ISS brought up serious health issues that include loss of muscle and bone mass, vision problems, poor fluid distribution, a loss of balance sense, spine misalignment, cardiovascular problems, and a weaker immune system. While we don't know exactly how the human body will cope in a low gravity environment for extended periods, settlers on Mars may struggle with some of these issues too. To counteract the risks, the settlers will have to do a lot of exercise, which further lengthens their working hours. NASA has even gone as far as to consider genetic modifications for the astronauts who embark on long-stay missions, to combat the dangers of radiation and microgravity, among others. This could even be plausible with current technology, although a lot of controversy on the moral limits of such manipulation arises. Still, even with all these considerations, there's no shortage of volunteers wanting to go. Every time there's been an opportunity, agencies and companies have received a barrage of applications from hopeful candidates. These colonies will depend on how technology evolves here, although at the moment it seems that we already have a lot, but not all of what is necessary to create bases outside of Earth. Do you think mankind will ever get a colony on Mars? With NASA's aim for the late 2030s, do you think that's reasonable?
And after my travel tour of the Red Planet, how sold are you on being among those early colonizers?
Have I scared you off? Or are you thrilled at the thought of rising to the challenge and carving out a foothold in the face of great odds? Remember, this could happen within our lifetimes. You or people you know could conceivably be among the first to ever live on another planet. Of course, going down in history. Against the backdrop of that, and filled with the curiosity to see what life would be like under a truly alien sky, perhaps a little part of you is tempted, which says all you need to know about humanity, given the context of that dusty, storm-covered planet that is Mars. There was a time when visiting Mars was a thing purely of science fiction, relegated to the likes of John Carter or Arnold Schwarzenegger's character Douglas Quaid from Total Recall. However, thanks to recent advances in technology, the first humans might be walking on Mars within this decade. They'll be brought there by Starship, a rocket in development by SpaceX, which hopes to get humans to Mars by as soon as 2030. Once a colony is established, many others will start making the 6-month trip to the Red Planet. Perhaps this is a thing that you might do in your lifetime. Even if made as a commercial vacation, the journey to Mars is no trivial cruise or long-distance flight. If you go, you will not come back the same again. You quite literally could be changed forever. I'm Alex McColgan, and you're watching Astrum. Today, we will be taking a look at Starship and imagining for ourselves what a voyage to the Red Planet might be like. SpaceX company founder Elon Musk has long aspired to take humans to Mars. In 2005, Musk first declared to the world his plans to create a long-term, high-capacity rocket, one capable of carrying massive weights into orbit. However, it took over a decade of development and tinkering with the idea for Starship to be first officially announced. Starship is a super heavy lift-launch vehicle made to deliver 100 metric tons to low Earth orbit and beyond. It is fully reusable, able to launch and then land itself thanks to high levels of control from its multiple engines as well as its flaps, which extend to slow its fall in atmosphere. Starship is a spacecraft of 2 parts. The first part, the Super Heavy booster, is a 69-meter tall behemoth filled primarily with 2 massive tanks of liquid oxygen and liquid methane fuel. It sports up to 33 Raptor engines, capable of producing between them around 76 million newtons of force. The Starship spacecraft, which is the second stage, sits on top of its Super Heavy booster. It's 50 meters long, with a diameter of 9 meters, and is equipped with a distinctive shiny exterior. This shine is important. Starship is not made from the usual carbon fiber, which is a material you might expect in a rocket, but instead a version of stainless steel, a similar material to what you might find in your knife and fork. Stainless steel is a surprisingly useful building material for rockets, it turns out. It can heat up to temperatures of over 1,300 degrees Celsius without melting or warping, which is useful when you intend your rocket to perform atmospheric re-entry. But more than that, it is cheap and easy to mass produce. This speaks to Musk's vision. He intends to produce entire fleets of these. In his mind, Mars is somewhere that humans will set up a serious presence, and when that happens, it's only natural that materials, products, and personnel will need to make the journey to and from the Red Planet. Which brings us to Starship's payload. As previously mentioned, this mostly hollow space is able to carry around 100 tons. It has a 9-meter diameter circular base and is 18 meters high, tapered to a point, allegedly because Musk thought it would be funnier to have a pointier rocket. It can be used to carry satellites, which can then be released into orbit for commercial ventures. However, SpaceX has made it clear that when it comes to the trip to Mars, they intend to put humans in this area. Currently, SpaceX has not revealed what the interior design of this habitation will definitively look like, but there are some preliminary ideas. So, let's explore those ideas. Let's imagine that in a couple of decades from now, we receive a call that tells us colonists are needed on Mars, and it's time to make the long trip. To begin with, you would travel to a SpaceX launch site, possibly in cooperation with NASA. and would meet up with your roughly 100 co-passengers. 100 passengers are how many SpaceX thinks it can comfortably fit inside of Starship, although Musk mentioned that this number could be as high as 200 if passengers were willing to really cram themselves in there. You might do well to get to know some of these people now, as unlike with a regular trip in an aeroplane, you are going to be spending a lot of time with these individuals. On an aeroplane, it is often tempting to watch a film, read a book, or go to sleep. However, you can't only do that for 6 whole months. These are the people you are going to be eating breakfast with. You will spend your free time together. You may form friendships. Human interaction is important for healthy psychology, and there is no way off this flight midway if you find there's someone you don't get along with. Better start off by making friends early. Together, you will then be ushered into the rocket itself. Likely for the initial launch, you and the others will need to strap into your seats. All that thrust beneath you will crush you with powerful G-forces that will push you into your chair. More intense than the most powerful roller coaster, a certain level of physical fitness will be an important element of this part. If there is a medical emergency on the flight, you are not going to get proper hospital treatment until you get to the other side. You will likely have been screened before traveling. Launch and liftoff will only last about 9 minutes. At some point in this journey, the super heavy booster will detach and drop back to Earth. The booster is reusable, and by controlling its descent, it will land perfectly on a landing pad, ready to be filled up with fuel again for another voyage. Thrust will switch over to Starship. While in the atmosphere, it will use 3 of its Raptor engines, but will switch over to the other 3 once the ship has reached true space. These secondary Raptor engines have larger nozzles, which are better suited to propelling the ship through space. All of this will be enough to get you up past the Kármán line and into space. You will now be traveling at thousands of kilometers per hour. However, as the boosters cut off and as gravity drops away, you will suddenly experience weightlessness. Gravity, as we discussed in this video, is only a form of acceleration. If we do not accelerate, even if we are traveling at thousands of miles an hour, we will float around. This will be a major feature of the next 6 months of your life. By now, the seatbelt lights will come off and you can begin to explore your environment. Current plans expect Starship to be split up into multiple floors or areas. At the bottom will be crew cabins. You will likely share a cabin with 1 to 2 other people, and conditions will be a little cramped. Above that, there will be a common area for gathering and social interaction. You will see exercise areas and equipment, an important part of space travel. On the International Space Station, where astronauts also spend 6-month stints, exercise takes up 2 hours of their daily routine. You will need to do this too to prevent the loss of muscle mass and bone density. Without it, you will lose considerable weight and may not be able to stand up once you reach Earth's gravity again. There may also be some emergency shelters. Hopefully you will not spend too much time in these, but it'll be important to acquaint yourself with where they are in the event of an unexpected solar flare. One of the greatest threats of space travel is radiation. Prolonged exposure can result in cancers and other negative health effects. Solar flares represent a hazardous spike in this radiation level, and the captain might at times require you to take refuge in these thick-walled shelters for the good of your health. Mealtime will be a little different from what you are used to. The food you will eat in space must be able to survive for months on end without going bad. There is no opportunity to restock. The International Space Station does not even have a fridge. All of this means that vacuum-sealed, rehydratable food will be the order of the day. Whatever you eat, be wary of mess. You will not be able to sprinkle salt or pepper on your food, as the low gravity will send this flying into the air. Thus, these will be provided in liquid form. As for water, well, the only way to carry enough water for 100 people to Mars is to have excellent recycling systems. So, anything that comes out of you will likely be siphoned off and recycled, only to be served back to you at your next mealtime. It's best not to think about it. Then again, this is not that different from what happens on Earth. All the water you drink has been through many other living things' systems multiple times. As I said, best not to think about it. Showers will not likely be present, as without gravity, water does not flow. Astronauts tend to use waterless shampoos and rub themselves with wet flannels. Toilets will be something you need to strap yourself down to use, and they will be vacuum powered to get rid of waste and to stop it floating around. Sleep will take a little adjusting too, as there will be no true night and day anymore, and gravity will not pull you down onto a bed. Think you could get used to all of this? Well, here is where the really strange things start happening. As you travel through space, you will start to experience changes. Under the effects of low gravity, you will start to grow taller. Some astronauts gained an entire inch of height after 6 months in space. Your face will become redder and puffier as your heart, so used to fighting against gravity to pump up blood through your system, will find itself too good at its job in a weightless environment. This change can lead to health issues, thickening of carotid arteries, and sight issues. These are not all fully understood by scientists, as there are not many examples of humans in space to test from. But perhaps the strangest of all, your very DNA will change. There is always some adaptability in human DNA. Certain genes are turned on or off at certain times in our life under certain conditions. In a twins study performed by NASA in 2019, 2 twins with identical genetic material were tested. One was sent up to space for 6 months, the other remained on Earth. When the 2 reunited and were tested again, it was found that the astronaut twins' DNA had changed in how it was expressing itself, creating differences between him and his brother. There were shortened telomeres, weakening of the immune system, and issues with bone formation. It's worth noting, upon arriving back on Earth, most of these changes in genetic expression reverted back to normal after 6 months. However, 9% of them did not. In ways we do not fully understand yet, spending time in space changes you, most likely because of the radiation the astronaut experienced. So, eventually you will arrive at Mars. Starship will fall at an angle and will use its flaps to shed an incredible 99% of its kinetic energy aerodynamically, traveling in a long arc through the atmosphere before eventually bringing you to the planet's surface. You will step out into the biodomes and sniff the manufactured Martian air. Starship will be checked over and then refueled using oxygen and methane extracted from Mars itself. As for you, you will have plenty of time to ponder. All journeys change us, but yours may be the one that you can never change back from. The you that left Earth will never truly return home. But then, perhaps that's just how it always is.
Contact has been lost with Opportunity since the 12th of June 2018. This pioneering rover survived an incredible 15 years on Mars's harsh surface, when finally a global dust storm blocked the sunlight from hitting its solar panels for several months. This video is a recap of Opportunity's entire mission, from its first landing to the final dust storm, with all the challenges it overcame and discoveries it made along the way. By the end of this video, I think you'll agree with me that it was a remarkable mission, and that it contributed a huge amount to our knowledge of the Red Planet. And it's this knowledge that has paved the way for the missions we are seeing today, like Perseverance. It answered questions like, did Mars once have a more substantial atmosphere? Did it have huge bodies of liquid water on its surface? And was it once more like Earth? And if so, what changed? I'm Alex McColgan and you're watching Astrum, and together we will follow the record-breaking journey Opportunity took on Mars. Let's start right at the beginning. Having launched on a Delta II heavy spacecraft, Opportunity landed on the other side of Mars from its sister rover Spirit, about 3 weeks after Spirit had already landed. Opportunity used a parachute to slow itself on its descent, and fired some rockets just before it landed. The effects of the rocket firing are evident from this lighter patch of ground, as seen by the Mars Global Surveyor. Opportunity first bounced, and then came to land inside a tiny 22-meter crater, now known as Eagle Crater, with the heat shield and parachute ending up a few hundred meters away. NASA scientists were so excited by this that they called the landing a hole-in-one, although they weren't actually aiming for this crater.
They didn't even know it existed until they got there, as Opportunity actually landed about 25 kilometers away from its intended target. As Opportunity emerged from its protective shell, the first thing it did was have a look around. Opportunity is equipped with a panoramic camera, which it can use to survey the area. It saw some outcrops only a few centimeters tall, made up of extremely fine dust, each grain far smaller than the grains typically found in Earth's sandstone. Opportunity and Spirit were primarily on Mars for its geology, the end goal being to see if Mars was ever a place that was conducive to life. The way that they did that was by looking at rocks for evidence of water, thus giving scientists an idea of what Mars might have been like millions of years ago, as rocks contain clues about their history. Opportunity explored the outcrop closely over the course of the next few weeks, already discovering evidence that in the past some kind of moving current had made the bedrock dip, although it wasn't clear if it was water that had done this, or volcanic flow, or wind. You can see this in this image, as the thin rock layers are not parallel to each other. On Sol 30, or Opportunity's 30th Martian day on its surface, it got close to the outcrop and used its rock abrasion tool to drill into a section of the rock face. As it did so, it found something known to geologists as vugs, or voids in the rock, the result of crystals having been eroded away. The rock also contained hydroxide ions, meaning water was likely present when the rock formed. Next up for Opportunity was to dig a trench in the soil for further analysis. It did this by digging its front wheels into the soil while the back 4 wheels held it in place. After some shuffling about for 22 minutes, it had made the trench 50 centimeters long and 10 centimeters deep. Under the top layer of soil were some things it had not seen before, including shiny little pebbles and grains so small this microscopic image can't even distinguish between them. Over the course of the next few Martian weeks, having discovered everything it needed to, Opportunity powered out of the crater at an average speed of 1 centimeter per second, and headed towards the next biggest crater in the vicinity, Endurance Crater, which is about 200 meters wide. On its way, it passed by this tiny little crater called Fram. It took a photo, but didn't stop for long. On Sol 84, it reached the edge and had a look inside. Mission planners already knew that Endurance had many layers of rock to be investigated and wanted to have a closer look at them. Opportunity circled around the crater, looking for a good entry point, as getting in wouldn't be a problem, but getting out might. By Sol 127, mission planners decided to drive Opportunity into the crater even if it couldn't get out, as the value of science that could be garnered was too promising to pass up. So, on Sol 131, it carefully edged its way over the ridge of the crater and tried to reverse back to see if it could. Luckily, the angle of the rim was only 18 degrees, well within Opportunity's known safety margin, so the excursion into the crater began in earnest. Opportunity went on to spend 180 sols in the crater. It explored an area called Karatepe, where it saw various layers in the bedrock. It went near to, but not into, some sand dunes, as mission planners didn't want it to get stuck. It saw some wispy clouds similar to Earth's cirrus clouds. And lastly, it went to a cliff face called Burns Cliff, an impressive looking cliff face with various layers separated by broken up rocks and dust. It finally left Endurance on Sol 315. During the time there, the data collected by Opportunity meant that scientists were able to confirm that water didn't just cover this area once, but it was in fact episodic in nature, with floods that would have washed across this landscape before drying up again. At any rate, the water here would have never been that deep. After that substantial discovery, the next stop on its adventure was to investigate its own heat shield. On the way, it came across a rock that was later confirmed to be a meteorite named Heat Shield Rock. It was the first meteorite to be identified on another planet. Opportunity then set a course for Erebus Crater. It pressed ahead through a region called the Etched Terrain to search for more bedrock. While traversing this area, on Sol 445, Opportunity got stuck in a 30cm sand dune. Things did not look good for the rover. All 4 of its corner wheels were dug into the dune by more than a wheel radius. This dune came to be known as Purgatory Dune. It stayed motionless for just short of 20 Martian days as mission planners frantically tried to figure out how to get it out. They simulated the scenario on Earth and tried various methods before they ordered Opportunity to try anything. On Sol 461, the rover advanced a few centimeters to see if it was doing what their tests had predicted. Over the course of the next 20 Martian days, Opportunity moved a few centimeters, took a photo of the progress, and sent the results back to Mission Control. By Sol 483, Opportunity had successfully escaped the dune and all 6 wheels were on firmer ground. It would have been disappointing if it had travelled for a year on Mars just to get stuck by a 30cm dune. Opportunity studied Purgatory Dune for another 12 Martian days before setting off again on its way to Erebus Crater. During its journey, mission controllers uploaded updated software to Opportunity to prevent it from getting stuck again, with software designed by learning what happened from the experience at Purgatory. With this new software update, it was ready to carry on its adventure at Erebus Crater. As Opportunity approached Erebus, it came to sections of ground where the bedrock was exposed. Mission controllers named this section the Erebus Highway. As we know, Opportunity's main mission was to search for signs of water on Mars, clues of which can often be found in the planet's rocks. It used its rock abrasion tool to carve circles into the bedrock, and with its microscopic camera, it compared the different structures of the rock to search for evidence of water. You'll notice by here that Opportunity's tracks are in front of the rover. This is still the front camera, but sometimes mission controllers drive Opportunity backwards to even out the wear and tear on the equipment. Erebus is a very old and eroded crater, filled with sand with only a few outcrops showing. You may not have been able to tell it's a crater from the ground perspective because it's so shallow and eroded. It only really becomes visible from the satellite photos. It is about twice as big as Endurance Crater at 350 meters in diameter, but Opportunity never actually went inside the crater as there was only more dunes in it. Instead, it stuck to the rim, avoiding larger dunes as it went. Even while carefully maneuvering around these dunes, it hit some soft sand and its wheels sunk in. Luckily, the software that was installed only a few weeks previously noticed that the wheels were slipping and it stopped its drive command. You see, Opportunity is not controlled in real time by a person on Earth with a joystick. There is too much latency for this, between 6 minutes to 40 minutes depending on the proximity of Earth and Mars. So instead, Opportunity is given drive commands. Using these same navigational images you see here, and comparing it with satellite-based imagery, mission controllers command Opportunity to drive forward a certain distance, where it will then take a new photo to show its progress. The software that prevented Opportunity from getting stuck meant that mission controllers could get the rover to reverse out without another several-week delay. During Opportunity's time there, it collaborated with ESA's Mars Express orbiter. The Mars Express images the surface of Mars from orbit to search for different types of materials. Without actually sampling the surface, the data it collects can be hard to interpret. Opportunity, however, can physically interact with the surface material, confirming whether what the Mars Express data showed was correct or not, helping them to refine their future observations. While Opportunity was near Erebus, it was also able to see an incredible transit of the Sun from Mars's closest and biggest moon, Phobos. As it was still making its way around Erebus Crater, a big dust storm hit, and Opportunity went dark for a few days. Very interestingly, you can see the difference the dust storm made to the rover as the camera goes from having a clear image to having some dust particles visible. Also, dust settles on the solar panels, meaning it can't generate as much electricity. Very fortunately though, Mars has occasional cleaning events, where wind or even a dust devil will pass over the rover, blowing the dust off the solar panels and camera. Because Mars is so dry, this dust is not at all adhesive, and the dust is so fine, almost as fine as cigarette smoke, that it doesn't take much at all to shift it off. You can notice this cleaning happen over time too if I speed up the footage. Look at this fleck of dirt here, and how it disappears over time. Opportunity doesn't have a means of clearing this dust off by itself, so it has always relied on these cleaning events happening, which, thankfully over the course of the 15-year mission, they did. Sadly, however, during the time at Erebus, Opportunity encountered its first mechanical fault. Its arm was getting stuck all the time, as you can see here. There was a broken wire, although the motor still worked if it was given more power. After careful deliberation, engineers decided the best thing to do would be to only stow the arm away while traveling long distances. Over short distances, it would be kept in a hover stow. This replica is being used to test how it can travel with the arm out in this hover stow position, where the arm is out but it bends back at the elbow towards the rover. They thought it would be better to have the arm stuck while it was out rather than to try and stow it away to find it could never be used again. At least it would be somewhat functional like this. Over the course of the mission, up until this point, it was also encountering a problem with a heater for a motor in the arm that wouldn't turn off. Engineers managed to get away with switching it off with a T-stat switch, meaning a thermometer switch would cut power to the heater if the motor got too hot. But as Martian winter drew near, there would be less sunlight. There wasn't enough power to have the heater on all night. They fixed this by completely disconnecting the batteries at night. This led to another problem, where there would be very big swings in temperature between day and night, meaning the motor would likely wear out faster. At this point in the mission, this motor stalled altogether. Engineers temporarily fixed it by applying more current through the motor, although as a precautionary measure, they stowed the arm outside the rover at night in case the motor permanently stalled. You'll start to notice this in the camera view from now on. By February 2006, or Sol 744, Opportunity visited its last site around Erebus crater called the Payson Outcrop. This outcrop of fine layers shows a diverse range of primary and secondary sedimentary textures formed billions of years ago. The structures that were observed here were likely caused between a mix of wind and water processes. By Sol 766, Opportunity had left the rim of Erebus and was on its way to the biggest and most impressive crater yet, Victoria. It journeyed through large ripple sand dunes, a type of dune we don't have on Earth. However, Opportunity tried to stick to paths of exposed bedrock, as these are much easier to traverse, and it can stop and investigate along the way. These cobble fields are a bit of a mystery, as we are unsure how they formed like this. On Sol 833, Opportunity almost got stuck again. Previously, mission controllers were thrilled by the meters of progress per day Opportunity had been making towards Victoria, but in this sequence, it took 4 days to get out of this dune, which they named Jammerbugt, a Danish term for the Bay of Wailing. Nearly 200 Martian days after it left Erebus, it arrived at Victoria. And what it saw was amazing. High ridge walls, a steep slope in, and beautiful sand dunes in the center. It had already overcome so many obstacles, and this sight was the reward at the end. So, what was so interesting about Victoria Crater? Was it able to provide any valuable information about Mars that Opportunity hadn't picked up anywhere else? Victoria was always going to be an important landmark for Opportunity to reach. Although few thought Opportunity would last the 7-kilometer journey from its initial landing site, at this point Opportunity had lasted more than 10 times longer than its original design lifespan. Victoria is the biggest crater Opportunity had visited yet, being 730 meters wide. It was also the deepest, meaning ancient bedrock outcrops along the walls of the crater were exposed to the surface. Exposed bedrock contains the clues to Mars's past that Opportunity was looking for. Also, as you can see, Victoria made for an impressive sight, especially in contrast to this otherwise flat plain that Opportunity had landed in. In preparation for this new exploration site, mission controllers uploaded new software to the rover, which would enable it to decide whether to send back an image or to extend its arm in preparation to sample an interesting rock outcrop, and even improve the intelligence of the rover to detect obstacles it should avoid and to make its own path around them. Who would have had to have gone through hundreds of images and wait through painful latency delay for commands to be sent to the rover. At its furthest point, the latency between Earth and Mars can be upwards of 40 minutes. This is one of the reasons why it took 3 years to only travel 7 kilometers up until this point. To test this new software update, mission controllers had Opportunity drive towards a patch of rubble, and settings were adjusted to make Opportunity think that this rubble was a no-go zone. In reality, the biggest of these rocks is only 10 centimeters tall, meaning Opportunity could have easily driven over it. But they didn't want to test the systems on something that could actually damage the rover if it went wrong, so they chose these rocks instead. As you can see, the rover adjusted its course around the dangerous area and took this panorama so mission controllers could see how the rover responded to the new program. Opportunity began to circle the outskirts of the crater, imaging it as it went. It came across a few cliffs or capes along the way, imaging them with a very clever technique called a super resolution mosaic. These images have a much higher resolution than the camera on board Opportunity is capable of, and the way they did this was by taking lots of photos of the same thing, and then in post-processing on Earth, they combined the images to provide the resolution you see here. On a side note, this technique is used in many different fields, including microscopy and astronomy. Scientists say that the layers you see in the rocks found in all these cliff faces are due to a geological process called cross-bedding. They believe these layers are ancient sand dune deposits, which is why the lines are inclined upwards and not just horizontally. From these lines, they predict that this used to be a sand dune field not unlike the Sahara Desert on Earth. While this science data was very useful, mission controllers were primarily looking for a passage down to the crater floor, and they thought they found one here by the Valley Without Peril. On closer examination though, it was decided that the slope was too steep. Opportunity investigated a couple of cliffs while it was there, and even came across another meteorite called Santa Catarina, before mission controllers decided to drive the whole way back to the original arrival point at the crater to try and head down by there. This site was chosen because the slope was within the safety limits of the rover, plus the ground was made of flat, exposed bedrock, which meant it wouldn't have much wheel slippage. On the 28th of June 2007, or 1,200 sols into the mission, Opportunity prepared itself for its descent. But just as it perched itself on top of the slope, the biggest dust storm Opportunity had seen yet rolled in, decreasing the brightness of the sun by 96%. That's not quite as bad as it sounds, as the dust also scattered some of the sunlight towards the rover too, meaning it was generating 128 watts on the darkest day compared to its usual 700 watts on a clear day. But this is bad news for a solar-powered rover. That kind of power level isn't enough to keep the rover going. In fact, anything under 150 watts means the batteries begin to run flat. So operations were cut back substantially until the storm was over, and Opportunity was commanded to only communicate back to Earth once every 3 days. If the batteries did run flat, the components on board Opportunity could be damaged due to the intense cold on the planet during the night. Typically, the motors have heaters powered by the batteries during the night to keep the motors warm. If the batteries run flat, there would be nothing to stop there being extreme temperature differences between the night and day. At the equator, anything up to 20 degrees Celsius during the day and minus 75 degrees Celsius at its coldest at night, which would damage the sensitive components. The reason for this temperature variability is because although Mars does have an atmosphere, it is 100 times thinner than Earth's, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. Going back to the batteries, if they reached a critical level, Opportunity was also designed to trip a low power fault. This basically disconnects the rover's batteries from all but the most essential systems of the rover, putting it to sleep as it tries to charge its batteries with whatever available sunlight there is. Every sol, the rover would check the battery level to see if it could reconnect the other systems, and if so, it would then re-establish communications with Earth. This low power mode could mean that the rover stays asleep for only a few days, but it could also go on for weeks or even months. Chances are at that point, even if it did switch back on, too many of its components would be broken and it wouldn't be able to function anyway. Back to the dust storm. At the start of July 2007, mission controllers initially thought it would only last a week, but by the 15th of July, the storm had reached its peak. These are true color images showing a time lapse of the storm, and as you can see, it does get very dark. Thankfully, the severity of the dust storm was not quite enough to trigger the low power fault this time, although it did get worryingly close for a while. Eventually, by the 21st of August, or Sol 1271, the storm had cleared enough so that Opportunity could start to move forward again. Sol 1291 saw Opportunity finally enter the slope of the crater, but like it did before with the previous crater, just after it entered, it backed out again to assess the amount of wheel slippage from the slope. As it happened, wheel slippage did exceed the mission controller's threshold of 40%, so the rover stopped with 2 of its wheels still over the lip of the crater. After 2 days of decision making, mission controllers decided to press ahead regardless, and an extended exploration into the crater began. As Opportunity descended, it took some time to investigate any interesting looking parts of the exposed bedrock. It also took some images of the cliffs on either side of it. I think these images showcase just how steep this slope that Opportunity is sitting on, roughly 20 degrees. Opportunity didn't venture too far into the crater, as only sand dunes were found towards the base. It spent its time examining this light patch of bedrock, taking various pictures and using its rock abrasion tool to investigate the rock structure. It was determined from the data Opportunity collected that this area was likely not ever so hospitable to life. So mission controllers picked the next waypoint on their journey, Endeavour Crater. If you thought Victoria was big, look at this mammoth. Endeavour was thought to contain some clays, meaning water was once there, so Opportunity started its journey out of Victoria. At this point, on Sol 1502, Opportunity encountered another fault with its arm. No matter how much power they put into the joint, the arm wouldn't move from its stowed position under the rover. Sol after sol passed and the joint refused to move, until they determined the time of day the joint had the least electrical resistance, which was just at dawn before the heater for the motor switched off during the day. When that time came, they put as much power as possible into the motor and it worked. Not risking ever stowing it away again, engineers had to determine how to maneuver the rover safely without risking damage to the arm. Opportunity then began its 2-year trek towards the Endeavour Crater. This is Endeavour Crater, a huge but shallow crater at 22 kilometers across and 300 meters deep. But why Endeavour Crater? Due to the distances involved, it would take a long time for Opportunity to get there. So what's so special about this place compared to anything Opportunity had seen before? The most compelling reason, and indeed one of the science goals of Opportunity, was to find evidence of past oceans on Mars. At this point, in 2008, the theory that Mars once held an ocean on its surface was only just starting to get solid evidence thanks to the Spirit and Opportunity rovers. Opportunity at this point had discovered that water once existed on the places it had visited, but these places were no more than shallow floodplains which dried up periodically, not a true ocean. On the other hand, the Mars Reconnaissance Orbiter had spotted what was believed to be clays around Endeavour crater, clays being hydrated minerals which could have only formed from water being on the surface for extended periods there. Could Endeavour have been part of a more permanent ocean? And if there really was a surface ocean, are there clues to indicate that it could have harboured life? Mission controllers had to find out. And so, Opportunity left Victoria Crater and began its arduous journey south. The mission team were determined to reach their destination as quickly as possible, while also keeping a lookout for anything of interest along the way. Opportunity made good time across the Meridiani Plains, and by Sol 1818, it had travelled more than 3 kilometers. Nothing noteworthy really happened until Sol 1947, where a large rock was spotted. The mission team decided to investigate, discovering that it was a meteorite which they named Block Island. In fact, large rocks seemed to be the only thing to keep Opportunity busy, later spotting another one called Shelter Island, and a third called Marquette Island. Marquette Island was of particular interest to scientists though, as they believed this rock was part of the ejecta from a large meteor impact, meaning this rock would have come from deep in Mars's crust. Scientists could tell because the grains within the rocks are coarse with a basalt composition. The coarseness indicates it cooled slowly from molten rock, allowing crystals time to grow. Had it formed near the surface, the crystals within it would have been a lot smaller, as it would have cooled a lot quicker. Opportunity was never alone on Mars. It had a sister rover named Spirit, which was exploring the other side of the planet at the time. They both landed on Mars at roughly the same time, and had both far exceeded their original expected lifespan of 90 sols. At this point, they were 1,900 sols into the mission. Although, just like Opportunity up until this point, Spirit had encountered some mechanical failures too. Most notably, one of its front wheels jammed only 700 sols into its mission, meaning it dragged this wheel along as it travelled. In a way, I almost think Spirit was NASA's darling between the two rovers. Spirit often got more media attention for the things it was discovering on the planet. However, it was around the time Opportunity explored those rocks that Spirit, on the other side of the planet, attempted to drive over a sand dune and got its wheel stuck deeply in the sand. Spirit's operators began the long process of attempting to get it unstuck through simulations and testing on Earth-based replicas. Meanwhile, Opportunity carried on its long journey to Endeavour. By Sol 2138, Opportunity finally reached a landmark of note, Concepcion Crater. It is only 10 meters wide, but probably the youngest crater visited yet, evidenced by the exposed rubble and ejecta. Nothing particularly new was found there compared to any of the bedrock Opportunity had examined in the past, which was simply sulfate-rich sandstone containing peppercorn-sized spheres known as blueberries. At least the crater provided a contrast to the vast expanse of rolling sand dunes. 8 months had passed since Spirit got stuck in the dune. The sand that enveloped its wheels was particularly fine, and the process of excavating Spirit was exasperated by its jammed wheel. During this recovery process, another of Spirit's wheels jammed, meaning only 4 of the 6 now worked. The Martian winter approached for Spirit, and it was getting less and less sunlight to power its batteries. Until finally, a low power fault occurred on the rover and its systems disconnected from the battery. Spirit went silent. Mission controllers attempted for months afterwards to regain contact with the rover, but NASA eventually called an end to Spirit's mission. For the first time since it landed, Opportunity was now alone on Mars. Opportunity's long slog over kilometers of sand dunes to reach Endeavour was becoming taxing for the rover. Perhaps overly anxious not to have a repeat of what happened to Spirit, mission controllers decided to reroute Opportunity's course, a longer route, but hopefully a less arduous one. This route would also take it by what was named Santa Maria Crater. By Sol 2244, Opportunity set a new record for the longest lasting mission on Mars, finally beating Viking 1's mission duration. Opportunity could begin to see the rim of Endeavour, spotting the landmarks of Cape Tribulation, Cape Byron and Cape Dromedary. However, even 100 sols later, it was only halfway to Endeavour from Victoria. It had made good time considering it has a top speed of 5 centimeters per second and often went half of that to be safe, with frequent stops to look out for potentially problematic sand dunes. You'll notice the rover's tracks are ahead of the rover in this time lapse. This is because there is also a navigational camera on the back of Opportunity, allowing it to drive forwards or in reverse to evenly distribute wear and tear on the motors. Although, another reason right now was to protect Opportunity's extended arm, which, as I mentioned in the last episode, got stuck in this position. On Sol 2449, Opportunity finally arrived at Santa Maria Crater. It's a 90-meter wide crater and was important to mission controllers as there was already evidence here of hydrated sulfate minerals. As I mentioned, hydrated minerals can only form under bodies of water over extended periods of time. So this was an exciting precursor to what they really wanted to investigate around Endeavour, which was still a tantalizing 2-year journey away. Opportunity also stopped here to take a spectacular time-lapse of a Martian sunset or two, with one of the time-lapses showing a transit of Mars's biggest moon Phobos across the sun. Over 2 years had passed in just this one episode. Opportunity had soldiered on well beyond its expected mission lifetime of 90 sols, and even outlived its sister rover Spirit. It and the mission team had earned a rest at Santa Maria, and they all spent 3 months happily examining rocks and unlocking secrets about the history of Mars. After that, it was onward and upwards for Opportunity towards Spirit Point, a point around the rim of Endeavour, an inspiring commemoration of the mission's loss on the other side of the planet. After spending 3 fairly uneventful months at the Santa Maria Crater, Opportunity headed towards the closest hill on the crater rim, known as Cape York. Along the way, it came across a few small craters, some of which were very young, with ejecta from the impact strewn across the place. But Opportunity didn't stay for long. Approaching Endeavour, Opportunity was finally able to see some variation in the landscape after years of simply crossing flat plains of sand dunes. Peaks and capes started to rise up on the horizon as Opportunity approached the crater rim. On Sol 2709, Opportunity finally arrived at Cape York, and specifically a place known as Spirit Point, named after Opportunity's sister rover that had come to the end of its mission on the other side of the planet only a few months previously. Opportunity had travelled over 30 kilometers up until this point, 50 times further than the original planned mission distance. Mission planners decided not to go into the crater, as points of interest were again found around the rim of the crater. Bedrock is exposed to the surface there, which allowed Opportunity to study the oldest rocks it had seen so far on this journey. It was also around these peaks and capes along the rim where the hydrated minerals or clays were detected by the MRO. Perched on top of Spirit Point, Opportunity looked over Endeavour, providing a perspective about just how big this crater is. From the onset, Opportunity began discovering phenomena never before seen on Mars. You may remember from the previous episodes that the soil found around the areas Opportunity had thus far explored contained countless smooth, tiny, round rocks, nicknamed blueberries. Around Endeavour, no blueberries were to be found. Instead, the soil looks much coarser, the rocks sharper and not as rounded. Mission controllers were so impressed by the variation of this area compared to the initial landing site that they said that this section of the mission provided the equivalent of a second landing site for the price of one. The first point of interest Opportunity examined was a large ejector rock called Tisdale 2. It was unlike any other rock so far examined on Mars. It had volcanic characteristics, but contained more zinc and bromine than previously seen. It was determined to be a type of breccia, old rock fragments having been fused together. This was further evidence for water. The impact that threw this bit of ejector likely released hot underground water that deposited zinc in the rock. Just a short distance from Tisdale 2, Opportunity discovered perhaps the most conclusive evidence that water existed on Mars thus far. Can you guess what it is from this picture? Look closely at the bottom of this image and you'll see a thin white line exposed in this outcrop. A close-up examination of the vein revealed it to be gypsum, the alpha particle X-ray spectrometer on the rover's arm detecting the minerals calcium and sulfur, together making calcium sulfate. They named this vein the Homestake deposit, and it likely formed from water dissolving calcium out of volcanic rocks, which combined with sulfur, and was then deposited as calcium sulfate into an underground fracture that later became exposed at the surface. The impact that threw Tisdale 2 likely had something to do with this vein as well. If this is the case, it shows that water once flowed through underground fractures on Mars. Later analysis of the data Opportunity collected showed that not only was this likely to be gypsum, but also that the water here would have been much less acidic than it would have been around other locations on the planet, meaning it could have been more conducive to life. Martian winter was soon setting in, meaning shorter days and a lower sun in the sky. For a solar-powered rover that can't adjust the angle of its solar panels, this is not the ideal situation, but for the first time since the mission began, Opportunity had the opportunity to spend the winter on a slope aimed towards the sun, meaning that for this winter it would be confined to an area named Greeley Haven. This area was not only aimed towards the sun, but it was also rocky, meaning Opportunity had a lot it could examine during these few months. This 360-degree panorama shows the tracks of Opportunity as it carefully navigated its way to its winter lodgings. The fact Opportunity had to wait a few months in one spot was actually handy, as the Mursbauer spectrometer in the rover's arm uses radiation from cobalt-57 to determine the composition of a sample. However, cobalt-57 has a half-life of only 9 months, which wouldn't have been a problem for a 3-month mission. Opportunity was now 8 years in, and examining the composition of a rock now took weeks, compared to the half hour it would have taken at the beginning of the mission. When it was not examining rocks, it could also use the time to study tiny wobbles in the rotation of Mars to gain insight about the planet's core. It requires weeks of radio tracking the motion of a point on the surface of Mars to measure changes in the spin axis of the planet, something which couldn't be done before as Opportunity was always on the move. The wobbles they were looking for would indicate whether the interior of Mars is still molten or not. Opportunity's weight also meant it could examine the effects of wind on the dunes of Mars from a ground perspective, even at a microscopic level, using the microscopic camera on the rover's arm, checking for slight changes over the months it was stationary. Months had passed, and winter was turning again to summer. On Sol 2947, Opportunity moved again for the first time since it set up camp in Greeley Haven. Luckily, everything that was functioning from before seemed to still be functioning, and Opportunity headed out to the next point of interest. MOR data suggested clays were present in this area, and the mission team were determined to find it. A beckoning outcrop was spotted around Sol 3057, and the microscopic camera revealed something about it that no one was expecting. Much like Opportunity's landing site, these smooth polished blueberry rocks were observed. However, this time they were very much a part of the rock. They were also smaller than what Opportunity had seen before, only a few millimeters in diameter, and not rich in iron like the landing site blueberries. A few of the exposed blueberries observed had been eroded away, revealing their internal structure. Scientists describe these blueberries as crunchy on the outside and softer in the middle. They are different in concentration, they are different in structure, they are different in composition, they are different in distribution. It was quite the mystery. Opportunity had just one more place to visit on its trip around Cape York, and that was the clay patch dubbed Whitewater Lake. On its way there, the Earth and Mars were just going through a phase called solar conjunction, where Mars is behind the Sun, which blocks communications between mission controllers and the rover. This has happened a few times during the course of the mission already, but this time Opportunity gave mission controllers a bit of a scare, as during the communications blackout, Opportunity's onboard computer reset into standby mode. Thankfully, communications were restored, Opportunity booted back up properly, and it carried on to Whitewater Lake. And it was there Opportunity discovered Esperance, the pale rock in the upper center of this image, which is about the size of a human forearm. This was it, the treasure scientists had been looking for. Esperance's composition was found to be higher in aluminium and silica, and lower in calcium and iron, more so than any other rock Opportunity had examined in more than 9 years on Mars. Testing found that this rock had a clay mineral content due to intense alteration by water. Opportunity spent weeks here, making sure the measurements were correct, getting everything it could get done before Martian winter came around again. Sights were set on a place called Solander Point, a sun-facing slope on the next hill 1.5 kilometers further south. Opportunity left Cape York on Sol 3344, having spent 9 Earth years, or 5 Martian years, on Mars's surface. It found the best evidence out of any Mars mission that neutral pH water once existed on Mars. Even though this huge discovery had been made, Opportunity still had a lot ahead of it. Mission controllers wanted more evidence of water, and they had their sights set on Solander Point, about 1.5 kilometers further south from Esperance. Martian winter was starting to come around again, which brings with it a reduction in sunlight, from the length of the day to the angle of the sun in the sky. To maximize the generation of power for the little rover, Solander Point was chosen as it's a north-facing slope, meaning as Opportunity explores the area, its solar panels would be angled towards the sun too. It was also believed to contain more evidence of hydrated minerals and exposed layering in the rocks, as spotted by the Mars Reconnaissance Orbiter. 1.5 kilometers doesn't seem so far away, but Opportunity was a slow rover with a top speed of only 2 centimeters a second, and it often traveled half that just to be safe. Scientists didn't want it to crash into rocks or get stuck in sand dunes, so Opportunity would move forward a bit, look around for hazards, and repeat the process. Along the way, the floor underneath Opportunity looked very peculiar. It was primarily large chunks of rocks, smoothed off at the top with sand and dust filling the gaps, almost like a random mosaic. Flat rocky ground is the ideal terrain for Opportunity, so it made good progress on the way to Solander Point. Much like the rest of the mission, blueberries were spotted again, rounded rocks a centimeter or 2 across. By Sol 3390, Opportunity made it to its winter lodgings and began work on the slope. Even while working here, energy production was very low, hitting only 270 watt-hours per day. Any lower than that, and the rover would have gone into a type of hibernation mode. This was due to the Martian winter, but also because dust had been settling on the rover's solar panels, and there hadn't been a cleaning event for a while. This low power mode meant the work around Solander Point was slow, and it wasn't until Sol 3530 that a cleaning event finally pushed energy production up to 370 watt-hours per day. Cleaning events occur when wind blows extremely fine dust off the panels. Because Mars is so arid, there's nothing adhesive about the dust. So even though Mars's atmosphere is so thin, these dust particles can be easily blown off. A bit like blowing dust off the cover of a book. Dust settles on the rover over time, especially during the massive dust storms that are so big they can be seen from space. Around Sol 3519, Opportunity spent the day examining a surface target. However, embarrassingly, the mesh they used to calculate the distances of objects to the rover was wrong, meaning the instruments on the arm were off by about 5 centimeters. So the images taken were blurry, and the alpha particle X-ray spectrometer couldn't properly detect what it was looking at. This was quickly rectified, and the usual crisp images started coming back to mission control again. A bizarre discovery that was noticed just a few sols later was something known as Pinnacle Island. Opportunity often took days to examine certain patches of ground, but scientists noticed some variation between one photo and another taken a few days later. This rock seems to have appeared out of nowhere. Mission controllers weren't so impressed though, putting it down to a nearby meteorite impact, or even Opportunity bumping the rock into place with one of its wheels. A flyby of the Mars Reconnaissance Orbiter revealed no fresh impact, so that discounted that theory. But mission controllers sent Opportunity on its merry way without investigating the rock further. This caused outrage online, with people suspecting aliens left the rock there as a means of communicating with us on Earth, or that it was a type of fungus that had grown over the 12 days between photos. Some people even went to the lengths of suing NASA over their reluctance to investigate Pinnacle Island further, by imaging it with the microscopic camera on board Opportunity's arm. However, before that really got going, as Opportunity looked back on Pinnacle Island, the mystery was solved. Opportunity had indeed cracked a rock in half, as can be seen by the tracks left in the sand. As far as we are aware, this is the first time something like this has happened on its whole mission, but the chances of it occurring were likely increased as Opportunity's arm was getting less and less mobile through wear and tear. This means that the rover itself now has to turn in order for the arm to reach specific objects, instead of the arm simply reaching across. Another problem that was becoming more and more persistent for Opportunity was the onboard computer randomly resetting. Although Opportunity was always able to turn back on, each reset wasted about a day's worth of science activities. By Sol 3749, these resets caused about half the month to be missed. Mission controllers narrowed the problem down to the onboard flash memory. Flash memory can get temperamental after repeated use, heightening the risk of losing new photos before they can be sent back to Earth, and so the decision was made to reformat the entire drive. This would not only clear the storage, but also identify any bad cells within the drive, so those cells can be avoided in the future. By Sol 3773, the reformatting was completed successfully. Soon thereafter, Opportunity reached Vodoviak Ridge, south of Salander Point. As this was going on, a visitor from the outer edges of the solar system was hurtling towards Mars. Its trajectory would take it just 130,000 kilometers above the planet's surface before it continued on towards the Sun. This visitor was again not an alien, but Comet Siding Spring, a visitor from the Oort cloud. The Oort cloud is found well beyond Neptune and the Kuiper belt, millions of icy rocks in orbits that take millions of years to complete. Because it had such a long time to accelerate towards the Sun from the furthest point in its orbit, the trip from Mars to the closest approach to the Sun only took 6 days. That's 56 kilometers per second. However, because of the close flyby of Mars, it meant that the spacecraft on and around Mars were actually in a better spot to witness Comet Siding Spring than we were on Earth. Mission controllers of the various missions were also a bit nervous about the dust particles that are ejected from the comet traveling at that speed, potentially impacting and damaging spacecraft in orbit around Mars. As such, Hubble, as well as spacecraft around Mars, all began observations of this visitor. Fortunately, mission controllers had already had some practice at this with Comet Ison, another comet that passed by Mars only the year previously. Comet Ison, however, was 80 times further away than Siding Spring would be, too far and too dim for Opportunity to spot. And unfortunately, it was day just as Siding Spring made its closest approach to Mars, but Opportunity was able to snap a couple of photos of it just before dawn. Can you spot it? Here's the annotated version of the same image. As it passed by, none of the spacecraft were damaged by ejected dust particles, but what they did observe from this flyby was completely unexpected. As it passed by, it plunged Mars's weak magnetic field into chaos, albeit temporarily. Unlike Earth, Mars doesn't have a magnetic field generated from within its core. Its magnetic field comes from plasma high up in its atmosphere, which generates a very weak charge. This is enough to deflect solar wind coming from the sun, but solar storms from CMEs and solar flares push past this induced magnetic field, stripping away atoms from the atmosphere. Comet Siding Spring had a very similar effect on Mars. Comets are also surrounded by a magnetic field, again induced from interactions with solar wind, this time with the comet's atmosphere, or coma. A comet's coma can reach out for millions of kilometers from the comet, meaning that as Siding Spring passed Mars, Mars was enveloped in its coma for a good few hours. This merged both magnetic fields for the duration of the event, with charged particles from both objects interacting strongly with each other, and the atmosphere of Mars actually lost some particles to space as a result. However, apart from the image Opportunity was able to take from the surface, all this went largely unnoticed by the rover. 2015 was quickly approaching, and Opportunity was heading for Marathon Valley, which would take the odometer reading of Opportunity to the distance of a typical marathon. Completing a marathon in 11 years? That's a pretty impressive finishing time. In celebration of this milestone, mission controllers took part in a relay marathon with a replica of Opportunity as they crossed the 42-kilometer or the 26.2 mile mark. But there was more to Marathon Valley than just a waypoint. There were interesting rocks here that mission controllers wanted to investigate. To get down into Marathon Valley, Opportunity had to go down the steepest slope it had faced yet, 32 degrees. Such was the steepness of this slope that dust that had built up on the solar panels began to flow off. After successfully descending down the slope, Opportunity first investigated a region known as the Spirit of St. Louis. It's actually a small crater, yet it has some outcrops exposed. Unfortunately, it was around here that the flash memory caused the onboard computer to reset again. Although mission controllers had narrowed down the problem to a specific cell bank on the flash drive, quarantining this section apparently hadn't completely solved the problem. The solution had helped somewhat though. A reset once a month is a lot better than the few times a day they were getting before the reformatting and quarantining. Eventually though, engineers decided to bypass the flash memory altogether and operate the rover in RAM-only mode. The danger there though was that RAM gets wiped if the computer switches off, meaning any scientific data not transmitted back to Earth is at risk of being lost forever should the onboard computer turn off. The northern edge of Marathon Valley was a ridge named Hinner's Point. To the south was a ridge named Knudsen Ridge. In these regions, Opportunity was again looking for clays, past evidence of liquid water oceans on Mars. Mission controllers detected clays on these ridges from orbit with the MRO, which correspond to these reddish areas seen in the enhanced color versions of these photos. Opportunity found these rocks to be brittle and to disintegrate a lot easier than other rocks it had previously observed, as well as having unusual compositions. They were unlike a lot of other rocks in the area. Although data collection was constant here, it was also extremely slow going. The alpha spectrometer on Opportunity's arm was losing its potency, meaning sample analysis that would have taken minutes at the beginning of the mission would now take in days or weeks. This was also combined with Opportunity's temperamental onboard computer, which was really starting to struggle. As a result, it took Opportunity well over a year to get through Marathon Valley. It began to head deeper into Endeavour, and was greeted with a spectacular sight. A dust devil was spotted on the crater floor. Spirit, Opportunity's sister rover, had seen dust devils in the past, but they were a lot rarer for Opportunity. It is believed that dust devils passing over the rovers had been responsible for the occasional cleaning events that removed dust off the rover's solar panels. Opportunity's next goal was again found further south, a gully that scientists believe might have been carved out by water. A gully had never been closely examined by a Mars mission in the past, so scientists were excited by what they might find. But getting there was tricky. On its way down the crater rim, it passed through a gap in this ridge named the Lewis and Clark Gap, down Bitterroot Valley to Spirit Mound. On its way down, it took some spectacular panoramas of various ridges overlooking the sand dunes stretching across the crater floor. Upon reaching Spirit Mound, Opportunity had been on Mars for well over 4,500 sols, roughly 12 Earth years. All things considered, Opportunity was in reasonable health and generating a very comfortable 450 watts of power from its solar panels. On its way to the gully, it would stop periodically to perform some science operations like imaging select rocks and measuring argon in the atmosphere. Opportunity finally reached the gully in September 2017. The gully was named Perseverance Valley. Scientists wanted to know whether it was water, ice, or wind that had carved this gully. From the shape of the gully, it certainly looks to have had something flow down it. Opportunity also spotted rocks aligning the channels. Could these have been deposited by water currents? As it turned out, Opportunity wasn't able to find anything conclusive. After several months of examining the area, Opportunity passed through 5,000 sols on Mars. And what better way to celebrate than by taking its first full selfie? You'll notice this image is blurry. That's because it was taken with the fixed focus microscopic imager on its arm. It was only designed for very close targets. In June of 2018, the MRO detected the formation of a dust storm. This isn't unusual. Mars has seen its fair share of dust storms coming and going on a fairly regular basis. Opportunity had even lived through some itself. However, within days of its formation, it was clear that this was going to be a big one. It very quickly spread across the entire planet, and mission controllers began preparations for a period of low power. On the 3rd of June, Opportunity was producing 468 watts of power. By the next day, this had dropped to 345 watts. By the 6th of June, it had plummeted to 133 watts. Dust caught up in this storm filled the atmosphere, obscuring the precious light from the sun to the point where it would have barely even been visible. The worst storm Opportunity had experienced up until this point was in 2007, where the atmospheric opacity, known as a tau value, was at 5.5. This was almost enough for Opportunity to not make it through. This storm, on the other hand, had a tau value of 10.8, almost twice as bad as the previous storm. Although operations were kept very basic, only sending back health reports every morning and evening, by the 12th of June, Opportunity fell into a continuous hibernation mode. The storm dragged on for months, and with each passing day, mission controllers lost more hope that Opportunity would wake up on the other side. 3 months later, the storm finally subsided enough for Opportunity to wake up from its hibernation mode, and efforts were made to re-establish contact with Opportunity. By October, the storm had cleared completely, but no contact had been made with the rover, even after 350 attempts. From November on, mission controllers hoped that if the rover simply had a lot of dust on its panels, that wind would blow a lot of it off. However, 1,000 communication attempts later, all the way through to February, mission controllers gave up hope and declared the mission dead.
Mer project off the net.
The 15-year, or 5,352 sol Mars mission had finally ended. And what a mission it was. Opportunity measured temperatures, atmospheric readings, the rotation of Mars, and more. However, the real prize was the definitive proof that Mars was once a world similar to our own, in that it held stable bodies of liquid water oceans on its surface in the distant past. While we may take that for granted now, when it was first confirmed, it was truly groundbreaking. Shortly before communication was cut off, Opportunity was in the process of sending back one last panorama of its final resting place. Its famous last communication was poetically translated to be, "My battery is low and it's getting dark," and its final image was of the sun obscured by the dust. And there we have it, a recap of the entire Opportunity mission. In 2003, a rocket launched from Cape Canaveral, Florida. Its destination was Mars, and it was carrying a rover that would achieve the impossible, Spirit. It was not designed to last more than 90 sols, yet it lasted 6 years. Not designed to survive Martian winters, it endured 3. Not designed to survive destructive dust storms, it survived several. And not designed to perform mountaineering, yet again, this pioneering rover did it anyway. With obstacles constantly thrown at it, Spirit kept going and explored the surface of Mars on its mission to find evidence of life on the planet or in its past. I'm Alex McColgan and you're watching Astrum. And in this supercut, I will take you on Spirit's complete journey both to and on Mars, the trials it faced, and the remarkable discoveries it made. Alongside its companion rover, Opportunity, whose journey I have covered in this popular series, Spirit was part of NASA's Exploration rover mission, an element of the Mars Exploration Program. This program had 4 science goals. 1. Determine whether life ever arose on Mars. 2. Characterize the climate on Mars. 3. Characterize the geology of Mars. And 4. Prepare for human exploration. Spirit was designed to be a crucial component of achieving these goals, with its main scientific objective being to search for rocks and soil types, then track down clues for any potential past water activity on Mars, a key indicator of life having once been on the planet. As scientists cannot yet go to Mars themselves, robot geologists like Spirit are essential for the success of the Mars Exploration Program and for the future of human space exploration. To undertake the mission, Spirit's designers armed it with a utility belt of tools. Around 185 kilograms in weight and roughly the dimensions of a golf cart, Spirit was equipped with panoramic and navigation cameras, a miniature thermal emission spectrometer for examining rocks and determining their origins, and 2 180-degree HAZ cams for observing the rover's surroundings. Meanwhile, on the rover's arm, there was a Musbauer spectrometer and alpha particle X-ray spectrometer for investigations into the mineralogy of rocks and soils, magnets for collecting dust particles, and a microscopic imager for high-resolution, close proximity images of the planet's surface, and a rock abrasion tool for exposing fresh material for examination by the onboard instruments. These were deployed on the robotic arm to get the instruments as close to the material as possible. Spirit's design also incorporated pieces of the fallen World Trade Center's metal, which were used to protect cables on the drilling mechanisms. And as for its name, Spirit, initially known as Mir 2 Rover 2, was named through a student essay competition. The winning entry by 9-year-old Sophie Collis read, "I used to live in an orphanage. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for the Spirit and the opportunity." Now, with its mission, its design, and its name in place, it was time for Spirit to begin its journey. Launching before the Opportunity rover, Spirit took off from Cape Canaveral, Florida on the 10th of June 2003. The spacecraft then went into a parking orbit around Earth as it prepared to embark on its intercept course with Mars. When the time was right, the upper stage of the Payload Assist Module fired and sent the spacecraft into a heliocentric orbit that would lead it to intercept the red planet. But its trajectory wasn't perfect. During its trip through space, Spirit had to course correct 4 times, eventually leading the spacecraft to approach Mars on the 4th of January 2004, after a journey of almost 7 months. But the most dangerous part was still ahead of it. To land on Mars, a spacecraft has to go through EDL, Entry, Descent and Landing, a process that takes a spacecraft hurtling through space at incredible speeds and gets it down to 0 km per hour on the surface of Mars, using only a heat shield, a parachute, some rockets, and an airbag. It's a process that happens so quickly and is subject to so many variables that scientists refer to it as the 6 minutes of terror. And with no time to call back to Earth and recalibrate, the computer has to solve any problems it encounters on the fly. This is what happened. Spirit approached the atmosphere of Mars at 19,000 km per hour. 15 minutes before entering the atmosphere, the lander, inside its protective aeroshell, separated from the cruise stage. As Spirit hurtled towards the planet's surface, the heat shield's temperature rose to 1,600 degrees Celsius, while inside the spacecraft remained room temperature. At an altitude of 4 to 5 miles, the spacecraft slowed down to around Mach 2 and the parachute deployed. 30 seconds later, the aeroshell's bottom heat shield was jettisoned. 10 seconds after that, the rover began to unreel down a tether at a rate of 70 meters per second, all as it raced towards the planet's surface. It was here that the radar began to detect the surface of Mars, and the onboard computer began to determine when the retro rockets would have to fire. At about 5 seconds before the lander smashed into the surface of Mars, the airbags were deployed around it, and, below the parachute, the retro rockets ignited, bringing the lander's speed to 0. The boosters were needed because Mars's atmosphere has less than 1% the density of Earth's, and with that kind of air pressure, a parachute cannot reduce enough velocity on its own. 8.5 meters above the ground, the bridle was cut, and Spirit, complete with its protective airbag covering, fell to the ground at 14 meters per second. This section of the landing was extremely dangerous and vulnerable to chance. If the airbags hit a sharp rock at a wrong angle, the lander would be destroyed. And as it bounced almost 30 times, this was always a possibility. Luckily, no such thing happened, and Spirit rolled to a stop 250 meters from its point of the first impact. Spirit had landed. EDL was complete. The 6 minutes of terror were over. On January 4th, 2004, Spirit was on Mars. The place where it landed was roughly 12 kilometers away from the planned landing zone and inside the Gusev crater, a possible former lake inside an enormous impact crater. A natural target considering Spirit's mission. Once the airbag had settled, Spirit deployed and rolled out onto the surface of its new home and started taking panoramic images that would help the scientists at NASA identify potential geological targets. The images were transmitted using Mars Global Surveyor and 2001 Mars Odyssey, 2 spacecraft which were orbiting above the surface of Mars. These were the images that Spirit took. The first of these images was the highest resolution color image taken on another planet. This was compiled using 4 PanCam images high and 3 wide, creating a full-size image of 4000 by 3000 pixels. These individual images were taken in black and white, with 13 filter wheels allowing images to be produced in different wavelengths. Back on Earth, these same images were then combined to create the color image you're looking at now, that gives you a view of what it would look like to stand on the red planet. Take a look at what you see. Note the abundance of rocks and the rolling surface in the distance, features that the rover could explore. These are Anderson Hill, Brown Hill, Charler Hill, Clark Hill, Husband Hill, McCool Hill, and Raymond Hill. One area, a circular depression that came to be known as Sleepy Hollow, was a target for the lander due to its ability to provide insight into the interior of Mars. The landing site, surrounded by the aforementioned hills and geologic material, came to be known as Columbia Memorial Station, a name given in honor of the Space Shuttle Columbia disaster where 7 astronauts lost their lives. Spirit immediately began busying itself by exploring Sleep Hollow Crater, an area 9 meters wide and only 12 meters from the lander. However, it wasn't long before something threatened to derail the mission altogether. On the 21st of January 2004, or Sol 17, NASA's Deep Space Network abruptly lost all comms with Spirit. The team at NASA was perplexed. The following day, they received a beep through the network, which meant one thing: Spirit was receiving transmissions, but had determined that it was in a fault mode and would only respond to commands sporadically. This was a serious anomaly, but if it was a software issue or memory corruption instead of a hardware issue, it was fixable. Ordering Spirit to transmit engineering data, the team discovered that an error in the rover's sleep mode had caused it to waste battery and overheat, issues that could destroy Spirit if they were not rapidly fixed. This was further complicated when, on Sol 20, Spirit ignored the command "shut down, damn it" until from the team, which attempted to cause it to suspend operations. Time was running out. One theory about the rover's issue was that it was stuck in a perpetual reboot loop. Spirit was designed to reboot if it detected a fault, but if that fault occurred during its reboot process, then the rover would reboot forever. Determining that the error was in the flash memory, the team used a design feature that allowed the rover to boot without utilizing the flash memory, which successfully broke the reboot cycle. Alongside this, they discovered that there were too many files on Spirit's file system, which was causing issues with Spirit's operations. Luckily, most of these files were unneeded in-flight data and could be deleted, which they promptly did. They even reformatted the entire flash memory system. The result? On the 6th of February, Sol 32, Spirit was back online and free to explore the surface of Mars. But although it had already traveled across space, through the atmosphere of Mars, and survived the landing and a critical malfunction, its adventure was only just beginning. For Spirit and its instruments, Martian rocks were more than just targets to grind. They were time capsules that offered a glimpse into the planet's environmental past. The question for Spirit then was which capsule to open. One rock, named Sashimi, was close by and a straightforward drive, a tempting target, but there was a hitch. The surface of Sashimi was dusty, which would lead to Spirit's observations becoming obscured. The rock was also pitted, making it a poor match for the rover's grinding tools. Luckily, there was another option. Named Adirondack, this rock was roughly the size of a football, had a dust-free, flat surface, and a high level of cleanliness. It would be a trickier drive to get to than Sashimi, but such a good match for Spirit's tools that it presented an irresistible target. Venturing out into the vast Gusev crater, Spirit turned 40 degrees in short arcs for just under 1 meter, then turned to face the rock, finishing its journey with 4 short straightforward moves of just under 2 meters. This might sound specific, but for Spirit, navigating through the rocky terrain of the Gusev crater, this is how careful it had to be. The enormous Gusev crater, 166 kilometers in diameter, is roughly 3 to 4 billion years old. One theory, based on imagery and mapping, suggested that Gusev was an ancient lakebed sourced from the Ma'adim Vallis, a 700 kilometer long Martian outflow channel, much larger than Earth's Grand Canyon. This theory was one important possibility that Spirit had come to investigate. The rock abrasion tool, which we mentioned earlier, was Spirit's grinding and brushing tool. It was 10 centimeters long, and to take rock samples, it used a wheel coated in diamond dust and resin, which spun at 3000 RPM, giving the rat the ability to drill a 45 by 5mm deep borehole into rocks. Alongside this, the rat had 2 brushes that removed dust from the boreholes and gave the scientist the ability to make closer inspections. Astonishingly, for a machine that performed rock grindings on the surface of another planet, the rat only consumed about 30 watts of electricity, which is crucial given how conservative Spirit has to be when rationing its power consumption. Once the machine had cut the Martian rock, it provided Spirit's other tools with a smooth, clean surface that could be used for precise observations, such as the rover's microscopic imager that helped determine a rock's composition. Before performing any grinding, Spirit returned microscopic images, as well as Musbauer spectrometer readings of Adirondack. These were unprecedented readings, as no investigation like this had ever occurred on Mars or any other planet. These readings suggested that Adirondack contained minerals composed of magnetite, olivine, and pyroxene, not dissimilar from Earth's volcanic basalt rocks. But to confirm this, Spirit had to cut into the rock. On the 6th of February, its 34th sol on the planet, Spirit used the rat on Adirondack. Simply breaking open a rock might sound mundane, but remember how far from Earth Spirit had travelled to be able to do this. Not only that, but this was the first time humanity ever performed a rock abrasion on another planet to more easily identify its composition. Spirit was making history. Using the instruments on the freshly exposed material, it helped confirm the suspicion that the rock was volcanic basalt, and provided intriguing insights into the makeup of Mars. But what did Spirit learn? Well, Adirondack was a remarkably well-chosen target, because it turned out to represent a typical rock found on the plains of Gusev crater. Spirit's instruments showed that Adirondack, and later other Gusev rocks, were indeed filled with pyroxene, plagioclase, olivine, and magnetite materials. These made the rocks picritic basalts, similar to earth-bound rocks called basaltic komatiites. Adirondack in particular has been ever so slightly altered, possibly as the result of thin films of water interacting with the rock. These small quantities of water may have induced mineralization. One key giveaway is that Gusev rocks such as Adirondack were easier to grind compared to similar rocks on Earth. It was time to move on. On the 5th of March, Spirit trekked to Humphrey Rock, where it found some striking hints of water history on Mars. Humphrey was a dark volcanic rock, about 60 centimeters tall, with bright material in its interior crevices, alongside cracks that appeared to be minerals crystallized from water. These were revealed when Spirit used its rat to scrape away the rock's surface by 2 millimeters. These materials were another signpost that water did indeed exist on Mars, and either interacted with Humphrey after it formed, or was contained within it. This was a huge step forwards, potentially discovering the answer to one of the Mars exploration program's key questions. Did life ever arise on Mars? If we are to ever colonize Mars, answering this question is crucial. Spirit's investigation wasn't destined to end at Humphrey Rock. Our rover had more work to do. On Sol 65, March 11, 2004, Spirit journeyed to an impact crater known as Bonneville Crater, home to Spirit's heat shield, which was jettisoned during landing. Bonneville Crater was located within Gusev and was not particularly large. It had a diameter of roughly 210 meters, a depth of 14 meters, with a rim that rose 6.4 meters above its surroundings. Given this low depth relative to its crater, Bonneville was likely a secondary crater, formed from the ejecta of a much larger impact elsewhere. It was also relatively pristine, and not subject to any water erosion. However, as interesting as the crater might have been in theory, once Spirit reached the crater's edge, no interesting target rocks could be found, so the rover avoided descending into the crater's belly. Instead, Spirit headed towards the Columbia Hills, which were briefly glimpsed from the Spirit's landing site. This journey brought Spirit into contact with another crater. On Sol 118, already outlasting its original mission target, it reached La Hontan crater, which was even smaller at 55 meters across and 9.1 meters deep, but it posed a serious risk to Spirit. On the southwestern side of La Hontan was a long sand dune, a threat to the stability of the rover's wheels. Spirit couldn't risk coming into contact with this and toppling over, so the dune was avoided. Even with obstacles like La Hontan's dunes, Spirit's path to the Columbia Hills was a relatively straight line. Spirit was directly controlled by engineers when the terrain became more complex, but otherwise was largely safe to travel autonomously for his lonely journey across the dunes of Mars. By Sol 159, Spirit had reached the foot of the Columbia Hills at a location called West Spur. As it got closer to the hills, foreboding signs indicated that the rover was beginning to age. Spirit's right front wheel began drawing up to 3 times as much current as the other wheels. This meant that the wheel could be stuck, and moving it required more effort, draining Spirit's limited energy and heating the motor to an inoperable degree. What was the cause of this? One possibility was that debris could have lodged into the wheel's mechanism, preventing rotation. Another was that congealed lubricant might no longer be spreading over the wheel's moving parts. Ingeniously, Spirit had heaters in the wheel to solve this very problem. But without knowing the true cause of the issue, Spirit needed to minimize damage in the short term. Moving forward, Spirit started using the front wheel sparingly, leaving the brunt of the effort to the other 5. That said, drag from the front wheel would have to be accounted for, and in instances where climbing steep slopes or difficult terrains became necessary, Spirit would have no choice but to use all 6 wheels. On Sol 174, Spirit began a 3,000 meter tune-up to help itself to get in better shape for its oncoming missions, designed to help it get through the next 3,000 meters. One fix was a front hazard avoidance camera calibration. This was necessary, as Spirit had begun to experience a 2 to 3 centimeter inaccuracy in predicting the actual location of targets. To help fix this, Spirit used various arm poses and images to refine its ability to target objects with its stereo hazard avoidance camera images. This was followed by a front wheel diagnostic and lubrication to help fix its rotation, as well as visual odometry tests to help Spirit navigate with greater speed. The tune-up was also where Spirit had its first, well-deserved deep sleep. This mode left the rover depowered overnight, allowing it to save energy spent on survival heaters and electronics usually present when it was napping. This was essential if Spirit was to save energy over its coming sols on Mars. But deep sleep wasn't without its dangers. As the survival heater was powered on, there was a risk Spirit's mini thermal emission spectrometer instrument would not power back on. So Spirit undertook 2 potentially final observations with the instrument before finally powering down. Throughout this, Spirit's solar panels were tilted towards the winter sun, conserving as much energy as possible and helping them overcome the interference from the setting sun and increased levels of dust. Once the tune-up had ended, Spirit spent the following sols studying many rocks across the Columbia Hills, such as the rocks named Clovis, Ebenezer, and Lutefisk. On Sol 188, Spirit found a solution to its issues with the front wheel. A solution more creative than diagnostics and lubrication. It started driving backwards. This helped Spirit improve performance and extend the lifetime of the front right wheel's motor. An example of the simple changes and clear thinking that kept the rover operational for so long. A solar conjunction delayed Spirit, but once it was over, the rover journeyed to the summit of Husband Hill, which sat around 107 meters higher than the surrounding plains of the Gusev crater. Aside from being home to views of Gusev, it was flanked by a beautiful albedo feature on its south side, rich with dark rolling sands, not unlike a dune on Earth, which gives Mars its distinctive texture when viewed from space. And now, by Sol 344, Spirit was in a good place to continue its mission on Mars. 344 sols. That's an incredible achievement for a rover that was only meant to survive 90. And yet, Spirit kept on going and going, providing more and more data for scientists. But
How much longer could Spirit last? The days marched on. Spirit entered the week of its first anniversary of landing on Mars. To celebrate, it began studying a rock named Champagne on the slopes of Husband Hill. Yes, even robots need to party. And as a robot, it enjoyed its champagne in the most socially unacceptable way possible, alone and with full use of its science payload. After these measurements, however, the Spirit team confirmed the existence of a minor short circuit of 0.1 volts. This short wouldn't affect the day-to-day operations of the rover, but it would make Spirit more vulnerable to subsequent damage. Otherwise, Spirit was doing well. The team continued to traverse up the soft, dusty slopes in increasingly complex maneuvers to ensure that our rover didn't become trapped, a traverse complicated by increased dust in the atmosphere, reducing the sunlight reaching Spirit's solar panels. Some of that dust had settled as a coating layer on the panels, which meant that Spirit's team needed to be extremely careful with how they planned their route and power consumption. Nevertheless, en route to Larry's Lookout, a point on Cumberland Ridge, Spirit analyzed two small rocks of interest, Peace and Alligator, before imaging a far larger rock much further away, but one the rover can never hope to reach: Phobos, Mars' largest moon, a 26-kilometer wide satellite that is due to impact Mars' surface in 10 million years. With its imaging task completed, Spirit ventured forth across Cumberland Ridge, but only briefly before it made an unplanned stop. NASA engineers noticed that Spirit had curiously churned up an intriguing area of soil during its maneuvers named Paso Robles. But what was it about this area of soil that captured NASA's interest? Paso Robles was found to contain incredible levels of salt and high levels of phosphorus. We're trying to work out what this means, but clearly with this much salt around, water had a hand here. A stunning and fortuitous find about the history of water on Mars, one that preceded another unexpected discovery through failure that we'll reveal later. To complete its journey to Larry's Lookout, Spirit deftly reversed large sections, which helped to relieve pressure on the failing front wheel. Instead of moving forward and pushing the struggling wheel into the ground, reversing the rover up the slopes dragged the wheel across the surface, saving Spirit energy. From Larry's Lookout, Spirit took this panorama on Sol 413. To the right, we can see Spirit's tracks. To the left is a rocky outcrop which is part of Cumberland Ridge. Beyond that lies the Tennessee Valley. This image was made with 108 frames, each composed of 5 images taken through Spirit's different filters, which creates an approximate true color image. In the center of the image, 200 meters away and 45 meters higher in elevation, is the summit of Husband Hill, Spirit's next destination. This was to be a difficult and energy-consuming journey, but Spirit had a chance encounter that greatly improved its prospects. Mars' dust devils on Sol 421 swept over the rover, clearing a year's worth of dust buildup and increasing its solar panel efficiency from 60% to 93%. Over the next 160 sols, Spirit tackled its way to the top. The increase in energy supply meant that Spirit was able to upload its data every sol with the Odyssey orbiter, allowing the team to capture lots of information en route, including on samples Paso Robles 2, Big Clod, Paso Dark, Methuselah, Keystone, Pittsburgh, Independence, and Franklin, without filling up its limited storage. On Sol 581, Spirit reached the first summit of Husband Hill, but our hard-working rover had no intention to stand idle. It took a 360-degree panorama composed of 653 images, for the first time imaging the entire deck of the rover in a panorama. Look how clean those panels are! During the nights on the top of Husband Hill, Spirit also imaged both moons, Phobos and Deimos, in order to measure their orbits more accurately. In the panoramic image,
McCool Hill and Raymond Hill are off in the distance in the center. McCool Hill was to be its winter destination, an area where Spirit could park up and angle its panels to the sun to maximize its energy capture over the darker months. But it never reached it. So let's continue Spirit's journey to see what it can achieve in its final 2.6 kilometers of life. On the descent of Husband Hill, Spirit was able to collaborate with the Hubble telescope to help calibrate data with atmospheric opacity readings, a sky survey, and calibration target readings. This helped with the accuracy of Spirit's measurements. Incredibly, Spirit's capability increased several times in its life, despite being 142 million kilometers away from its team of engineers. The multitasking rover installed an update as it was climbing Husband Hill, giving it the ability to drive sections autonomously, and another on Sol 1067 allowed Spirit to decide if and when to upload images, and whether to extend its arm to examine rocks. Spirit gained independence as it matured. There was one decision that NASA controllers still took on the descent of Husband Hill though: which rock to analyze out of a choice between two, Comanche and Miami. Comanche was chosen, and it turned out to be a rich subject to analyze. On Sol 690, Spirit discovered that Comanche was 1/4 magnesium iron carbonates, around 10 times higher than any rock previously analyzed on Mars. Carbonates are important in further understanding the hydrological history of Mars, as they are formed in the presence of water but dissolve by acid. So their discovery in high levels suggested that more neutral and hospitable bodies of water existed that could have been home to primitive life much earlier in Mars's history. A great discovery, but Spirit continued on tirelessly, and it reached its next checkpoint on Sol 744, Home Plate. Home Plate features layered and weathered rocks, including this feature found on the outskirts. It's hard to imagine this being shaped by anything other than flowing water. But it was the flow of time that was shaping Spirit. The rover was charging towards the north-facing slopes of McCool Hill in 2006 when one of its wheels failed. Exhaustive tests back on Earth at the JPL test facility, replicating the failure, could not get the wheel moving again. Spirit was now only making progress by dragging the locked right front wheel. Martian winter was coming too, and as the light fades, so do Spirit's reserves. With these two factors combined, NASA made the call to abort the drive to McCool Hill in favor of Low Ridge Haven. The rover found a spot with an incline of 11 degrees, which was sufficient to see Spirit make it through another Martian winter. For around 8 months, Spirit remained on the ridge, taking images of its surroundings. In one of the images, engineers spotted two subjects that were possible iron meteors. These were given the names Zhongshan after the Chinese Antarctic base, and Allen Hills after an area in Antarctica where several Martian meteorites have been discovered, including the most well-known and noteworthy of these, ALH 84001. Found in 1996, NASA scientists suggested that this Martian meteorite may contain fossilized extraterrestrial life, and released this image you may recognize as it became front-page news the world over. Once the Martian winter was over, Spirit had far more energy to use, and it ventured out once again. In March 2007, Spirit unwittingly excavated a surprising discovery. In the soft and red Martian soil, Spirit's failed wheel gouged the Martian surface, exposing bright white silica. Not evidence for life per se, but the next best thing, evidence for potential life. In our video on the origin of life, we talked about deep sea vents and areas where hot gases and material from below the crust meets the Earth's surface. Some create the potential for life to start. Others offer life a haven for growth. NASA believes that the silica deposit was made in one of two environments. Either hot spring deposits, where hot water dissolves silica in one place and then deposits it elsewhere, like hot springs or geysers, or alternatively, acidified steam blasting existing rocks, stripping them of much of their minerals, leaving mostly silica behind, areas known as fumaroles. Whichever it was, both environments are very supportive of microbial life on Earth. Incredible to think, if Spirit had not malfunctioned, if it and NASA had given up too early, this discovery would never have been made. Spirit spent the next few months circling home plate, and in June 2007 received another life-saving spring clean of its solar panels. Spirit boosted its power generation from a dip of 120 watt-hours back to over 600. On November 6th, Spirit navigated to the western side of home plate and took another panorama. NASA published this photo as an astronomy picture of the day, which, on first inspection, looked like every other photo taken of the Martian landscape. But it was soon to receive worldwide attention. Can you spot it? Hidden in plain sight is a suspected humanoid life form. Let's zoom in to what was dubbed Little Bigfoot. On the right of the image, we can also see Spirit's tracks from Husband Hill. We are now a few hundred meters away from the end of Spirit's journey. Martian storms had been increasing in recent months, leaving the solar panels heavily covered with dust, as well as blocking up to 99% of the light through the atmosphere. Survival was becoming harder, and operations were now much reduced from its peak. The aging Spirit was generating only 128 watt-hours, which is less than the 150 it requires to keep itself warm. If the heating were to fail, then the rover's components would eventually fail too. Two small cleaning events took the energy output of the solar arrays to 372. This gave the rover enough energy to charge its batteries and begin to move again. But the flow of time is always cruel. Spirit began to experience unexplained memory gaps in April 2009, with the rover now only 4 meters away from its resting place. On Sol 1892, Spirit hit incredibly soft, dusty soil at a location named Troy, where Spirit would make its last stand. Underneath its wheels was jarosite, which is a mineral of iron sulfate. Jarosite has remarkably low cohesion, meaning that achieving enough traction to move was proving impossible. Despite efforts by the JPL back on Earth to explore techniques to escape the sand trap, no progress was made. On Sol 2155, NASA reclassified the mission as a stationary research platform. While there, our rover took measurements of the atmosphere and several more images, including its last panorama from Troy. Spirit was still able to perform soil studies and extraction tests because the functionality of its arm was still excellent. Spirit needed to have a busy research schedule to use the power it was generating to maintain good battery health. But the final winter was approaching for Spirit, and it was a bitter one. Over the next few months, the power generation continually dropped, and by Sol 2196, it was again down to the critical 150 watt-hours. Sometime on Sol 2208, it is believed Spirit suffered a low power fault. On a lifeless and quiet planet, Spirit's end was never going to be dramatic, but that's not to say Spirit went gently into that good night. Now forgotten by many who watched Spirit's landing, it came to rest on the edge of home plate, alone, with 2 broken wheels, a drained battery, and a legacy of scientific discovery. In its life of 2,208 sols, Spirit journeyed 7.7 kilometers and transferred over 128,000 images back to Earth. Its mission was an overwhelming success, achieving its objectives to further the understanding of the history of water and the chance of life on Mars. Its name lives on in the name of asteroid 37452, Spirit, and the Perseverance rover is carrying its memory today, with this a family portrait of the Mars vehicles. Spirit's story is one of overcoming. Both the Spirit and Opportunity rovers lived up to their names given to them by that 7-year-old girl called Sophie. Names inspired by the struggles and promise of her own childhood. So, it's fitting that as the Spirit's internal heaters turned off, as it froze under the Martian starscape, the rover's story came full circle and found its end right where it began with Sophie's. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. From its incredible launch on the 5th of May 2018 to the present day as it reached its ultimate powering down, InSight has been an incredible lander. It has peeled back the surface of Mars and listened to the planet's slow heartbeat to gain knowledge unseen by any mission that has gone on before it. It has faced adversity. From day one, Mars fought back with an unending assault to wear it down or catch it off guard. But ultimately, its contributions to our planetary understanding are irrefutable, and it did so with a surprising tool, the planet's quakes. I'm Alex McColgan, and you're watching Astrum. Come with me and discover how InSight did what it did, as well as exactly what it learned. In this supercut, we will explore the mission of InSight as it happened. In the early hours of the morning of the 5th of May 2018, at Vandenberg Air Force Base, Space Launch Complex 3E in California, NASA scientists waited in nervous anticipation at their computers. Outside in the darkness stood an Atlas V rocket, a nearly 60-meter tall, two-stage behemoth capable of lifting nearly 9,000 kilograms into geostationary orbit. Atlas V rockets like this one have launched dozens of times, but it's impossible not to feel a degree of nervousness with each new attempt. Last time this launch was scheduled, it had to be pushed by several months because of a vacuum leak involving the size instruments in its cargo. Over half the missions to Mars to this date had either never left the ground or failed once they arrived on Mars. Even at this stage, there is always a chance of something going wrong. The Atlas V was here to carry InSight, a lander tasked with uncovering Mars's inner structure by studying seismic vibrations. It was not the first lander to attempt this, but it hoped to be the first one to succeed. NASA had sent 2 prior missions to Mars with seismometers, Viking 1 and Viking 2. However, Viking 1's seismometer malfunctioned on landing and could not deploy, and while Viking 2's seismometer did manage to get readings, there was no way of telling whether what it read was a seismic vibration or just the wind. This degree of uncertainty made its readings less reliable. With InSight, NASA would attempt to close this potential source of error. The signal came. Scientists received their last weather reports. Launching a rocket is a risky business. Wind speed, cloud coverage, even solar weather can negatively influence a launch. All must be accounted for. But here, they were given the green light. InSight would be launched within the hour. InSight is a meter-high, 6-meter-long lander sporting 2 large solar panels in a similar design to the Phoenix lander. It comes equipped with multiple instruments for scientific research. It carries a seismometer with a windshield and a robotic arm that will place the sensitive instruments onto the flat surface of the Martian planet. With this, it will detect the vibrations caused by quakes in the Martian mantle or by meteor impacts. Through careful evaluation of the time delay between the various kinds of seismic waves from a single event, it will be possible for scientists to piece together Mars's inner structure with a greater degree of certainty than ever before. But that is not all. Attached is a suite of weather sensing equipment to eliminate any debate as to the source of the vibrations it was detecting, not to mention helping scientists to better understand the climate on Mars. And to give it an even greater understanding of the state of Mars beneath its surface, it carries a mole, a hammer-powered digging tool intended to burrow deep into the Martian soil and take temperature readings. A large drill would not be economical to carry, so this was thought to be a more efficient design. The better we understand the structure of Mars, the more we can learn about its formation, and with it, the formation of other rocky planets in our solar system, like our own. With InSight, we hope to learn if Earth is an anomaly in the solar system. Are many of the other planets like us? What does this say about our formation? And so, at around 4 o'clock in the morning, InSight launched for Mars, causing bone-crushing G-forces. The first stage of the rocket burned for just 253 seconds before its fuel was expended and it detached. Then the second stage, Centaur, kicked in. This burned for another 14 minutes, which was enough time to reach escape velocity. InSight had been built to resist the strain. This first stage was a success, but now it would be time for the long trip through space. It would take another 6.5 months to travel across the 484 million kilometers between Earth and Mars. These months would be quiet, serene, and cold as it drifts through the star-studded vastness of space. InSight's arrival on Mars would be quite the opposite experience. It would be fast, hectic, and hot. InSight entered the atmosphere 125 kilometers up at almost 20,000 kilometers per hour. This generated a lot of heat, roughly 1,500 degrees Celsius. Fortunately, InSight's final stage came with heat shields that were able to absorb this blistering fury. And once the lander slowed down enough, the heat shields popped off and a supersonic parachute deployed, further slowing InSight down. Yes, Mars does have an atmosphere, although it is very thin compared to Earth's standards. With the speed InSight was traveling though, this parachute still made a big difference, although it wouldn't be enough by itself to stop the lander from smashing into the planet. But fortunately, InSight had planned for this. Unlike the Mars rovers, which just had giant airbags to bounce on landing, this spacecraft came equipped with its own rockets to land. So InSight's legs sprang into position, ready for landing. Once the parachute slowed it down enough, that too popped off, leaving just the lander itself. It then used its onboard rockets to carefully reach the surface. This whole process took place over the course of 7 minutes. It touched down successfully on the 26th of November 2018. Upon impact with the surface, the rockets kicked up a lot of dust. This is not very good for solar panels, so InSight waited 16 minutes before deploying its solar array to let the dust settle. This impressive unfurling can be seen in this testing environment before it launched. On Mars, these panels generate around 300 to 600 watts under normal conditions. However, dust in the atmosphere does affect power generation, as clouds would on Earth, so this can be different every day. Let's pause now and take a look around. The view that greeted InSight seems bleak and inhospitable, but it would need to get used to it. This rock-strewn, flat, dusty terrain would be its home for at least the next 2 years. Now, InSight was intended to be a 2-year mission. Unlike rovers, it had no tools for moving itself around, but that would not be necessary to fulfill its purpose. Its mission was to sit, listen, and learn. It had a lot of work to do. InSight's mission to Mars had begun. Far above the thin Martian atmosphere, a strange new sight had arrived. 2 little lights twinkled in the night sky. These were not new stars. They were CubeSats, called Marco A and B, and they had been following InSight for the last several months. Their mission was to relay real-time information back to Earth about whether the landing had been successful or not, and if the solar cells had deployed. The Marco mission was a technology demonstration mission, so it didn't have any scientific instruments, but rather it carried different technologies to test. These satellites were really small, only the size of a briefcase. They were the first time CubeSats had been sent into deep space, and at the time, no one was sure how well they would do. But so far, they had performed exactly as hoped for. The Marcos began listening out for UHF frequencies from InSight with the antenna on the bottom of the spacecraft, ready to transmit that data back to Earth using this bigger antenna. This big antenna operates like a satellite dish on Earth, except they designed it to be flat so it could be space efficient. Amazingly, these satellites only generate 17 watts of power, yet are able to receive signals from the surface of Mars and transmit millions of kilometers back to Earth. Of course, NASA was not going to put all their eggs in one untested basket. If Marco A and B hadn't worked, InSight would also be able to communicate with some of the other orbiters already around Mars, like the Mars Reconnaissance Orbiter. The only difference is that the Mars Reconnaissance Orbiter can't relay information back in real time. These lights would not be in the sky for long though. After performing their mission, the Marco CubeSats would fly by Mars, unable to slow down enough to enter orbit, and instead go on forever to drift around the Sun. But that is not what InSight sees. InSight does not know the fate of the machines that broadcast its messages. All it knows is that it's time to open its eyes, and maybe call to Mission Control to let them know it had arrived at its destination okay. The first thing InSight did was to send back signals to Earth that it had touched down safely. Along with that signal comes its first famous image. This image is a little messy. As previously mentioned, a lot of dust had been kicked up by the landing, as InSight used descent rockets to slow its fall. Fortunately, InSight's team knew this would happen and attached a transparent lens over InSight's camera to protect it. Later, InSight would remove this lens to take clearer pictures for the rest of the mission. Meanwhile, another camera pointing under the lander revealed the effects of the rockets, which had carved out mini craters under the craft. InSight deployed its 2 circular solar panels, now that it could collect sunlight without dust reducing its efficiency. From then on, it was time to work. InSight quickly began collecting data, even before deploying any of its science instruments. The first thing it recorded was the Martian wind, picking up vibrations sensed by the seismometer still on the lander. This is what it sounds like, although I should note that you will probably either need a subwoofer or headphones to hear this. This has not been sped up. These literally are the vibrations caused by Martian wind going over the solar panels of the lander. The frequency of the vibrations converted to audio. For the benefit of those who can't hear it, here it is pitched up by 2 octaves. InSight can also detect changes in air pressure. Here is the air pressure changing as the wind blows across the lander. This audio has been sped up by a factor of 100 for it to be within human hearing range. What is fascinating is that we don't just have to imagine the wind passing by InSight, as it was also able to capture footage of water ice clouds passing by overhead, visibly showing the direction of the wind. Yes, although Mars is currently a barren wasteland, there is still a tiny amount of water vapor in the atmosphere. Now limbered up, its warm-up science done, InSight was ready for the main event. One of its primary missions on Mars was to listen out for seismic activity, but its seismometer, or SEIS, was still strapped down on InSight's body. It would need to use its robotic arm to lift its SEIS instrument and place it directly onto the Martian soil. But not just anywhere would do. If it was going to settle in for a long 2 years of listening, InSight wanted to choose the best patch of ground. Something flat, with no rocks in the way, so its windshield could lie flush with the ground and provide a perfect sound barrier, providing a means for SEIS to collect its data uninterrupted. And it had a team to help it. Almost immediately after landing, InSight started collecting 3D images of its surrounding area in order to find the perfect spot to place the seismometer. Based on those 3D images, NASA actually recreated this area as accurately as possible back on Earth, even going as far as using the HoloLens augmented reality headset to match up the surface of Mars with the environment they were recreating. Once the perfect site was chosen, the go-ahead was given, and Insight carefully used its robotic arm to place the seismometer on the surface of the planet. From there, it began detecting Mars's faintest vibrations. Then it was time for the mole, and it was here that things started to go wrong. Insight's mole was a piton-shaped self-digging tool designed to dig up to 5 meters down into the Martian soil, taking temperature readings every 10 centimeters, and then extrapolating these readings to estimate the thickness of the Martian crust. A drill that could go this deep would have been too large and unwieldy to bring to Mars. The mole's internal hammer would get around this problem by hammering itself gently into the soil and having the dust of Mars fall into the hole it was forming to provide it with friction. Insight's mole could in theory reach the 5-meter depth. Insight's mole had been tested in conditions recreated to be as similar to Mars's dusty surface as possible, only on Mars itself it wouldn't dig. Unfortunately, the mole only got 30 centimeters into the dry soil of Mars before getting stuck. Scientists back on Earth scratched their heads. Had it hit a very hard rock, or was the soil simply not providing enough friction? Either way, the mole was now stuck, tilted at an angle before it had even fully exited its housing. Earth-based teams attempted to replicate the problem and look for a safe way to pick up the housing around the mole and maybe use the robotic arm to straighten its course. They had to be careful not to damage it though, as the robotic arm had not been designed for such a task. After many weeks of deliberation, they split the task and started removing the housing to better see what they were doing. Carefully, they coaxed off the outer housing, but it would be some time before further progress could be made. If friction was the problem, scientists were considering trying to use the robotic arm to push down on the soil right next to the mole, hopefully giving it the friction it needed to start digging deeper. It would take careful planning before this method could be attempted though. It was July 2019 when the housing was removed, 8 months after Insight's arrival on the planet. It would be another 3 months before their next move was enacted. Meanwhile though, things weren't all bad. Back in April, Insight had detected its first Martian quake, and this is what it sounded like. Again, the vibrations have been sped up by a factor of 60, as the frequency would not be audible to the human ear. While data like this doesn't need to be converted to audio for scientists to use it, it is useful for us as laypeople so we can better grasp the data. What you will notice though is how sensitive the seismometer is. Even under the windshield, it can pick up vibrations caused by the wind. And even the robotic arm moving can be easily detected, even though it's a few meters away. Detecting seismic activity is not all Insight can do. Insight was acting like a little weather station on Mars, with instruments detecting wind, air pressure, and air temperature. As you can see, even at the equator, Mars is a chilly -25 degrees Celsius at its warmest at the moment, bottoming out at -100 degrees Celsius. These low temperatures are a threat to any mechanical Martian mission. The fluctuations into freezing cold can cause weathering on scientific equipment that can quickly break them. If it weren't for onboard heaters powered by Insight's solar panels, Insight would have already been in big trouble. Insight was also able to detect some gusts of up to 60 km per hour and low air pressures, about 6 millibar compared to Earth's 1 bar. With its first readings taken, but also with its first obstacles encountered, Insight's mission was underway to mixed fanfare. Let us jump forward now in time. Months have ticked by. Insight now approached its first year mark on Mars. Scientists had been considering the problem of Insight's mole. By this point, they began to be more certain that it was not an underground rock that had stopped the mole in its tracks. Scientists had chosen this landing site especially because there were few large rocks in the area, and the mole had been designed in such a way that it should have been able to go around small rocks. The team had taken their time to think through what might be causing the problem, doing their best to create a replica of the situation on Earth using data from InSight's cameras. This isn't a perfect process, as it's impossible to perfectly mimic the lower gravitational conditions of Mars on Earth, even with replicas made from scaled-down, lighter materials. But by October 2019, they had figured out that the likely problem was indeed a lack of friction. When taking photos of the soil around the now exposed mole, they saw that the soil in this spot was different from what they'd been expecting. Although the surface you see here certainly appears loose and dusty, ideal for hammering-based digging, only a few inches deeper there appeared to be a layer of cemented soil known as duricrust. These particles of duricrust stick together more tightly, which means they won't fall into the hole the mole is creating, and thus weren't providing the friction necessary to dig deeper. Scientists hadn't realized that this type of soil was here when they picked the site for landing, as it had been hidden under the surface. But what to do about it? While InSight was equipped with a robotic arm, the top of the mole was not designed to be grabbed by this arm, so they couldn't just move it to another position. And as you can see here, there is a delicate cable designed to relay data from the mole back to InSight, which would be damaged if they just pushed down on the top of the pole with the arm. So, their first plan was to place the arm next to the digging mole, pinning the mole in place. Perhaps this would provide the friction necessary to get it started. Unfortunately, this proved to be not enough. The mole floundered in the dust, making no progress. Next, the team tried to scoop soil into the hole the mole had created. This also proved unsuccessful. More months ticked by, marking the time between each painstaking attempt. Finally, in October 2020, a full year and 8 months after the mole first started to dig, scientists attempted to push the top of the mole with the robotic arm. Although this did cause the mole to successfully bury itself, the hopes that this raised were soon dashed. Even when completely submerged by the ground, the mole would not go any deeper on its own. By the 14th of January 2021, the team gave up on the mole altogether. Although they still felt they'd learned valuable information for future missions about the nature of Martian soils. I think they'll have a new respect for duricrust going forward. Fortunately, InSight's other scientific equipment had been working much more effectively during this time. SEIS, the seismometer, was doing a much better job of providing a glimpse into Mars's inner workings. SEIS had been listening to the sounds of Mars for over 2 years by this point, and had detected over 500 different seismic events. Mars does not have tectonic plates like Earth, but it does have volcanic regions that produce quakes from time to time. And quakes produce different types of vibrations, such as P waves and S waves, that travel through the mantle at different rates. By timing the difference between when these waves arrive and listening out for their echoes as the vibrations bounce off the inner layers of Mars, it can be possible to work out Mars's internal structure, as well as learn other fascinating insights. Scientists by this point had learned 3 interesting things from all this data. First, Mars tends to have frequent but small quakes, none more powerful than magnitude 3.7. Scientists were surprised that they detected nothing more powerful given how frequently smaller quakes were happening. Perhaps Mars was more static than was expected, or perhaps they simply hadn't been lucky enough to witness a big one. It was too early to tell for certain. Second, the wind hides quakes. Because SEIS is so sensitive, even with its windshield, it could hear the vibrations caused by the wind, and sometimes this masked the vibrations of small quakes, like static on a radio. During the windier part of Mars's yearly cycle, the number of quakes appeared to go down. This was likely just because SEIS wasn't detecting them. To counter this interference, scientists formulated a plan to bury parts of the seismometer using the robotic arm scoop, as this might reduce the interference from the wind. Finally, and strangely, Mars quakes do not have surface waves. All quakes create waves. 2 of the main types, primary and secondary waves, travel through the mantle. However, normally there are also surface waves that run along the surface of the planet crust. And for some reason, these were not being detected on Mars. Scientists are still not quite sure why, but wonder if this is evidence of extensive fracturing of the upper 10 kilometers of Mars's crust, which might be diffusing the waves. To find out more, it would be necessary to wait and collect more data. However, this is more difficult than it sounds. After 2 years, time was no longer on InSight's side. InSight had reached the end of its expected mission duration, and amazingly was internally still going strong. However, an external problem had arisen: dust. Little by little, fleck by fleck, dust had built up on InSight's 2 solar panels, the 2 solar panels that provided life-preserving power to its onboard heaters. InSight had no machinery to clean its own solar panels. Scientists had hoped that dust devils would blow away this dust in cleaning events, but although some dust devils had been detected, so far, by bad luck, none had passed over InSight. By February 2021, InSight was now only collecting 27% of its potential power intake. Choked of energy-giving sunlight, InSight was beginning to feel its age. Its spirit was willing, but its power reserves were weak. Faced with this, scientists had to navigate a delicate juggling act. They needed to decide where to send InSight's dwindling power reserves: to the arm, to the size reader, the radio, or the vital heaters that kept InSight alive. And by February, Mars was entering its winter period, as well as aphelion, the time in Mars's year when it's furthest away from the sun, and the furthest from its precious source of power. There was only one thing they could decide. They had to settle InSight down to hibernate, using its power mostly to keep its circuitry safe and warm. They hoped that come July, as Mars gets closer to the sun again, InSight could bring its other equipment back online. Hopefully, a cleaning event would come along and the science could continue. Spring arrived. InSight awakened from its hibernation, but as it powered up its scientific systems, it still felt weak. The dust on its solar panels remained and was only getting thicker. InSight was faced with its own mortality, the growing realization that it would never get better or be at its prime again. But in spite of its diminishing power, NASA had been so impressed with InSight's data collection that they extended InSight's mission for another 2 years. InSight rose to the task. With limited time left to it and the end nearing, it threw itself into its task. Up until this point, no quake larger than a 3.7 mag had been detected. If InSight could find something like that, it would be the crowning jewel in the data it had collected. But it wouldn't be easy lasting long enough. At the start of the mission, InSight's panels were capable of producing 5,000 watt-hours each Martian day. Now, they were only producing 500 watt-hours, about enough to power an electric oven for 10 minutes. It was now a race against time to find that last big quake before InSight powered down forever. Back on Earth, its team had its back. Scientists were keen to buy InSight that little more time that it needed to hopefully find that quake. And in early July 2021, they struck upon a seemingly crazy idea. How could you remove dust from solar panels when you only had a large, clunky robotic arm with a scoop? Counterintuitively, add more dust. Specifically, to slowly trickle sand down onto the panels using InSight's scoop while the Martian winds were blowing. Hopefully, by doing this, the wind would alter the trajectory of the sand so it would bounce off the panel's edges, but as it hit the panel, it would knock dust loose, thus removing it in the process. This plan might sound crazy in theory, but incredibly, in practice, it worked. Although it wasn't much, by doing this, InSight gained an additional 30 watt-hours of energy a day. This boost in power provided InSight with an extension of life. InSight made it through the summer of 2021 and into the following year, which turned out to be a game changer. In the final year of InSight's life, past the point where it should have died, it detected its largest quakes. In May 2022, the ground rumbled. Data streamed in. InSight's size sensor detected a Mag 5 quake. Mars's lack of plate tectonics makes this a true giant of a quake for the planet. Just a few months later, InSight's end neared. In November 2022, NASA scientists started to pack down their side of the project. With the data that InSight had collected, they started collating it into a package that will be accessible to researchers around the world. They packed up the Earth-based replicas of InSight and the Martian terrain that they'd been using. They prepared to announce to the world that InSight is in its last couple of weeks of life. But InSight's legacy is not in the metal of its form, sitting forever on the Martian landscape. It is in the things that it learned, the knowledge it brought us. So, for one final time, what did we learn? To begin with, thanks to InSight's data, we now know that Mars does indeed have a crust, a mantle, and a core, just like on Earth. However, that crust is much thinner than we expected. It contains 2 to 3 sublayers and descends 20 to 37 kilometers deep, compared to the Earth's, which can have a thickness of 70 kilometers. Its mantle is not as hot as scientists previously believed, and descends a further 1,560 kilometers. Finally, its core is larger than scientists thought, with a radius of 1,830 kilometers. Surprisingly, it is also less dense than expected. This has led scientists to predict that it is not simply made of nickel and iron, like the Earth's core, but that it contains lighter elements like carbon, oxygen, sulfur, and hydrogen. This is a fascinating insight. It explains why the core of Mars is still molten. Much like salt's ability to reduce the freezing point of ice, which is why you see grit thrown on roads in colder weather, these lighter elements reduce the freezing point of Mars's core. It also points to the origin of the planet. These light elements must have been collected into Mars in the very earliest periods of the solar system's history, as by the time Earth was formed, these elements were not around in as great a quantity, explaining why Mars's core has them and ours doesn't. They were also found further out, indicating that Mars must have been brought closer into the Sun's gravity as time progressed, before finding the stable orbit it navigates along today. It confirms that during the early formation of Mars, all the cosmic dust that came together must have heated up and become molten, thus allowing the heavier core metals to easily sink into the planet's center. During this period, or soon after it, Mars began to experience its dynamo effect. Mars today only has a weak magnetic field compared to Earth's. Most of this field is left over as residual traces of magnetism locked into many of Mars's surface rocks. However, back in its early formation 4 billion years ago, Mars's moving metals in its core created a massive dynamo, imbuing these rocks with their magnetism. When the planet cooled, hot materials were not able to move about as quickly as they needed to keep the dynamo going. In time, Mars's dynamo ceased to be. Thanks to the data provided by InSight, scientists will have a much better idea of the timescales involved in this dynamo. This is relevant because when we talk about magnetic fields and dynamos, those can affect what the atmosphere was like. And once we understand that, we'll have a clearer picture of Mars's early habitability. InSight might give us an idea of the time period when life was most likely to form on Mars. InSight has given us an incredible amount of raw data, including a fascinating comprehension of Martian weather patterns. Yet there are still many mysteries. Even though we now know the rough dimensions of Mars's inner structure, InSight's findings have actually disproved some previously existing theories. For instance, under a particularly volcanic region on Mars's surface, known as Tharsis, home of Olympus Mons, a volcano 2.5 times as tall as Mount Everest, there exists a hot spot of magma that feeds the volcanic processes we see in this region. Due to the absence of plate tectonics, it was unclear what was causing this hotspot, which seems to have been present, unmoving, for billions of years of Mars's history. Scientists originally thought that this hotspot was being fed by a lower mantle, but it turns out that Mars does not have a lower mantle. As such, it is back to the drawing board to explain what is causing this phenomenon. Still, these are the sorts of questions and discoveries that drive scientific endeavor. And the discoveries that InSight has given us will inform future missions for decades to come. Scientists will pore over the data, analyzing P waves and S waves, attempting to find patterns and meaning in the sounds of Mars's rumbling heartbeat. And who knows how much more we will discover as a result of this successful mission. If more comes in, I will keep you posted. But now that insight has powered down, as it closed its eyes on the scattered clouds and dusty plains of Mars, I hope that it can rest easy. In spite of its challenges and the ups and downs, it did what it came there to do.
Considering it's only 22 kilometers across, Phobos is one very interesting moon. It orbits closer to its planet than any other moon in the solar system. Its orbit takes it so close to Mars, only 6,000 kilometers from the planet's surface, that it orbits the planet faster than a Martian day. In fact, standing on Mars, you'd see Phobos rise and set twice in one day. It's so close to the planet that you must be standing near the equator to see it. Anything above 70 degrees latitude means the curvature of the planet would block your view of the moon. Being this close to the planet means that the tidal forces exerted on it are comparatively large, so much so that scientists believe that Phobos only has around 50 million years to live before it is eventually pulled apart completely and its debris crashes into the planet. You can see signs of this process on the moon in what scientists are calling stretch marks. The moon is thought to be made of rubble, and with powerful tidal forces exerted on it, fractures have started to appear as the rubble is pulled apart. Because of its close orbit, its orbit is also degrading or spiraling inwards by 2 centimeters a year. When Phobos is eventually pulled apart, a small portion of the debris may remain in orbit around Mars for a few million years, meaning Mars would have rings for a time. But from a hypothetical standpoint, is there anything that could be done to stop Phobos' demise? It's only 22 kilometers across. Surely all you would need to do is stick a rocket on it and boost its speed a little to give it a higher orbit. Well, let's say we wanted to increase Phobos' speed by 1 millimeter per second. In order to accelerate something in space, we need to throw some mass in the opposite direction. So, knowing that Phobos' mass is roughly 1 times 10 to the power 16 kilograms, gives us our required change in momentum. Next, we need to figure out how fast we are going to hurl this mass away from Phobos. Let's say 20 kilometers a second, which gives us the amount of propellant we require, 500 million kilograms. Shooting that much mass away from Phobos at that speed requires a lot of energy, 10 to the power 16 joules. That means to increase the orbital velocity by only 1 millimeter per second, we would need to shoot out the equivalent of an Empire State Building with the energy of a nuclear bomb. As it happens though, we would just need to counter the orbital decay of Phobos, which is slowing down the orbit of Phobos by roughly 0.002 millimeters per second over the course of the year, which gives us our drop of 2 centimeters a year. We can counteract this by using roughly 30 grams of propellant per second over the course of a year. This still adds up though. That's equal to 1 million kilograms per year, plus the energy required to shoot it out. So could we eventually save Phobos? Maybe. It would require a lot of resources though, just to counteract its orbital decay, let alone raise its orbit. A 22-kilometer moon doesn't seem very big, but it is still 2,000 times heavier than all the coal mined on Earth each year.
Some of you may have heard of the amazing feat produced by ISRO, or India's space agency, where they successfully inserted a probe into Mars's orbit on the first time of trying, for a relatively minuscule $66 million back in 2014. This made it the first space agency in the world to have a successful Mars mission on the first time of trying, plus it is the first Asian agency to get to Mars. This by itself is pretty impressive, but it's been in orbit for over 5 years now. So what has it done and seen around Mars? And has it contributed anything beyond what the NASA and ESA missions have already achieved? I'm Alex McColgan and you're watching Astrum, and together we will investigate the findings and imagery of the McColgan mission to Mars. McColgan launched from India in 2013 on board an ISRO rocket designed to insert satellites into orbit around Earth. As the rocket didn't have the thrust needed to get McColgan to Mars, the probe had to use some of its own fuel to leave Earth orbit, which it achieved gradually over several orbits. Upon arriving at Mars, it was inserted into a highly elliptical orbit. At its furthest point, McColgan is almost 80,000 kilometers from Mars, and its closest approach takes it only 420 kilometers above its surface. This orbit is much different from NASA's Mars Reconnaissance Orbiter, which remains close to the Martian surface in order to image the surface at a much higher resolution. This is due to the different science goals of the missions. McColgan does seem like more of a technology demonstration mission, although scientific instruments on board had a particular focus to study Mars's upper atmosphere. However, what I really like about this mission is that they put a pretty normal camera on board to image the Martian surface. This means the raw images are true color images, seeing Mars as you would see it if you were in orbit. Having a highly elliptical orbit also means we can view the whole of Mars in one go, reminiscent of the old NASA Viking missions. I must say that at this distance, Mars is a beautiful planet. The carbon dioxide and water ice caps are visible at the planet's poles. Various shades of rock sediment and dust patches across the surface provide an interesting contrast. Craters of various sizes span the planet. And of course, some of Mars's most interesting features are visible, like its long dormant shield volcanoes and huge valley structures. What's also visible, even from this distance, are some of Mars's famous giant dust storms. In this image, the dust storm spans thousands of kilometers across the northern hemisphere. These storms can last weeks to months, almost completely blocking sunlight from reaching the surface under the densest parts. Storms like these caused big issues for the solar-powered rovers Opportunity and Spirit. Some smaller storms can also be seen in some of the other global views of Mars. Orographic clouds are often seen over the volcanoes of Mars, and yes, these are water ice clouds. Although the atmosphere of Mars is a lot thinner than on Earth, and most of its water has been lost, there is still a small amount of water vapor in the atmosphere. And in this image, we see 3 smaller volcanoes, with orographic clouds forming over Elysium Mons, the center volcano. Orographic clouds form when air is forced higher as it moves over high terrain. During a closer approach over Elysium Mons, clouds are still visible, but more apparent are the trenches around the volcano. These are called fossa, trenches formed by the stretching of the plate they reside on, often caused on Mars by the sheer weight of the nearby volcanoes. The fossa widen as more material falls in. Think of it like a series of connected sinkholes on Earth, but instead of material being eroded under the surface causing the pit to open up like on Earth, on Mars the cause is due to a fault under the surface, sometimes up to 5 kilometers deep. A close-up examination of one of the fossa reveals something interesting. Right in the middle of this image, you can see what appears to be a tall, wavy structure. McColgan inadvertently captured a giant dust devil, the shadow of which stretches out for several kilometers. Once you notice that one, you'll realize there's actually a few in the image, each with a long, windy shadow. Orographic clouds have also been seen over Olympus Mons, the tallest volcano in the solar system. From the base to the peak, Olympus Mons is 3 times taller than Everest and is 600 kilometers wide. As a result, it is easily visible and recognizable even from this altitude. From this view, you can also easily see where lava from ancient eruptions has flowed down onto the plains surrounding the volcano. Looking a bit further across, you see 3 more big shield volcanoes, with a few smaller ones to the north. You'll also start to notice this weird patch, which looks almost like a labyrinth, aptly called Noctis labyrinthus. In a similar vein to the Elysium fossa, Noctis labyrinthus is thought to have formed because of the huge volcanoes to the northwest, but this time perhaps due to collapsed magma chambers deep under the surface. Research is ongoing. Connected to Noctis labyrinthus is the famous scar of Mars, Valles Marineris. What I really love about these images is that, just like the Viking missions, water ice fog can be seen filling the chasm. This valley is 4,000 kilometers across, and channels seem to flow out of it to the east into chaos regions, similar but smaller than Noctis labyrinthus. This hemisphere of Mars is lower than the rest, which indicates these outflow channels, which do look a lot like river channels on Earth, flowed into a once ocean. Ground-based rovers have since uncovered further evidence for this ocean, finding hydrated minerals in these regions. Another really interesting visual landmark on Mars is Kasai Valles, north of Valles Marineris. Again, this shows a very interesting outflow channel, starting in the east and flowing to the west, depositing into the same region but further north as Valles Marineris in the south. Most scientists propose these channels are carved out by mega flooding events in the distant past, when liquid water was abundant on the Martian surface. There's also some argument that glaciers carved out these channels. In fact, there are a lot of outflow regions heading into this once ocean. Here's Ares Vallis, again probably carved out by mega flooding events. All these channels are too wide to have supported a constant river system, at least at this size. A very large yet odd crater-like structure can be seen from the McColgan images. This is Orcus Patera, 380 kilometers long at its longest point. Scientists are a bit baffled about how this could have formed. Craters are always circular, plus Orcus Patera isn't very deep at only 500 meters. Volcanic activity could be a cause, but there's no caldera. And so there have been no theories that scientists can settle on so far. What do you think it could be? Some of the images focusing on the limb of the planet have also been able to see Mars's atmosphere, which I think is quite beautiful. Some very oblique shots can even see a cloud layer high in the Martian atmosphere. And due to McColgan's ecliptic orbit, sometimes Mars's moon Phobos comes between the planet and the probe, imaged here against the backdrop of the planet. The last thing I want to showcase in this video is the prevailing wind direction on some parts of the planet. Even though we are quite zoomed out by here, in this image, showing a few thousand kilometers across, we can easily see where craters have blocked the darker dust from moving across the surface with the wind. The wind direction in these parts must have been like this for a while for it to be so noticeable from space. A closer look at the surface shows how this effect can happen with smaller craters too. The Mars Reconnaissance Orbiter has been orbiting Mars for 10 years already. On board the spacecraft is a very special scientific instrument called the HiRISE camera. It turns the spaceship into a scanner, imaging the surface of Mars in incredible high definition and detail. The camera it uses is not like a conventional camera, which captures everything in a set frame. Instead, it's like a photocopier that scans an image line by line. This is especially convenient for an orbiter, as it is moving around the planet anyway. HiRISE has taken some of the most stunning images of another celestial object I have ever seen. I wanted to do a bit of a different video, investigating HiRISE's true color images while explaining what it is you are looking at. Today's video will focus on the polar regions of Mars. I'm using Google Earth so you can see where each image was taken. Google Earth surprisingly also has the Moon and Mars included. The first image is found near the North Pole, near a group of sand dunes. Coating these dunes are the closest thing to snow you're gonna see on Mars. This is actually a frost made of carbon dioxide. You see, most of Mars's atmosphere consists of carbon dioxide. And because Mars can get much colder than Earth, and with a much lower air pressure, it means during the winter on Mars, some of this atmosphere condenses onto the surface. It's very similar to how water vapor freezes as frost on a cold night on Earth. However, the frost on Mars is seasonal, and when spring comes around, the CO2 will sublime back into the atmosphere. This is the process of a solid turning straight back into a gas. The next image is found in a crater near the South Pole. Craters near the poles tend to be a bit more protected against the sunlight than flatter surfaces, which means the frost lasts a bit longer into the spring than normal. You can still see the frost in this image, although you will notice these dark blobs too. These are called seasonal halos, as they appear in the spring. What is happening here is sunlight passes through the couple of meters thick ice sheet, heating the dusty surface beneath. The ice near the surface sublimes, creating an air pocket of increasingly pressurized carbon dioxide. Soon cracks form in the ice sheet, releasing the carbon dioxide as gas jets into the atmosphere. These jets also kick up a lot of dust hundreds of meters into the air, which is what causes these dark deposits all over. These jets are thought to look something like this, and must be quite the spectacle up close. Researchers theorize that the ground would rumble while standing on these thick dry ice sheets while the jets go off all around you. What I really find interesting about this image is some of the deposits have veins coming from them. That is thought to be the finest and lightest dust pulled out from under the ice by the sudden release of gas once the cracks form. This leads us nicely on to our next image, which again is found near the South Pole. I'm using a height elevation map this time so you can see how this next image is right in the middle of a big sand dune. In this image you can clearly see that there's a prevailing wind as these gas jets were going off. This is why all the dark deposits are in fan shapes. Further across the image, however, you can see the jets on this side of the dune were going off at a different time, so there was a different prevailing wind direction. The shape of the dune could have also impacted the wind direction for this other side. The dark spots are between 20 to 100 meters wide. In this image we are in the southern hemisphere again, but this time a little higher north. Because we are further away from the pole, there is not as much of a permanent frost throughout the year. When the ice is present, it looks very thick, even appearing blue at some points. Contrast that to the same crater, but about 2 Earth years later, and you can see the sand dunes that were hidden under the ice. With both images overlapping each other, you can really see what seasonal variations do to the surface of Mars. And what video about the polar regions of Mars would be complete without a look at the polar ice caps? These permanent features are here for the whole Martian year and are extremely thick, a few kilometers thick in some places. These patterns form with sublimation of dry ice during the polar summer. Under the dry ice is much more stable water ice, which does not melt all year long.
The Mars Reconnaissance Orbiter has been very busy during its 10 years in orbit around Mars. One of its specialized instruments, called the HiRISE camera, has been imaging huge portions of the surface of Mars in incredible high definition. I'm Alex McColgan and you're watching Astrum, and today we're going to be focusing on what it has seen over Valles Marineris, Mars's giant scar. This canyon is seriously deep, 7 kilometers deep in some parts, and extremely long at over 4,000 kilometers. It starts with Noctis Labyrinthus to the west, a large maze of spectacular canyons, and ends to the east in what appears to be an outflow channel, perhaps emptying into a once ocean. This is especially evident with the MOLA altimetry map. First of all, I want to give you some scale for these images, and also the size of the canyon walls of Valles Marineris, as saying 7 kilometers deep offhand doesn't really give you a sense of how big this canyon really is. This black and white image of the plains above the canyon wall is 5 kilometers across, and zooming in, the color image is 1 kilometer across. That's the scale I'll be using throughout this video. Now have a look at this. Approaching the drop, we start rapidly descending down into the canyon. Layers of bedrock can be seen extruding from the dust, notably a different color, indicating they are made of different things. The further down we go, the more colorful the bedrock gets. Incredibly, the wind's erosion at this point can be seen, as well as trails of boulders that have fallen down and left a path in the dust. And finally, the canyon levels off, although this isn't actually the bottom. Seeing this for the first time pretty much floored me. It is unbelievably impressive. But let's have a look at what else Valles Marineris has in store for us. Here is a cliff face along the side of Ganges Chasma, where weathering from wind erosion can be seen acting on the cliff face, exposing the dark and hard lava flow layers sticking out from the dust. A mineral deposit can be seen on the plains here, on top of this section of the cliff face that looks like it could fall at any moment. Interestingly, we can compare these jagged and rough layers to some smooth yet resistant layers further up in the image. These could be sediments laid down by water activity that were more resistant to erosion than the surrounding dust. Going further along, we find a lot more of these lighter mineral deposits along the walls. But what can you find at the bottom of the canyon? Well, you may have seen something similar to this on Earth. Sand dunes sweep over the canyon floors, but not sand as we know it. We are used to silica-rich sand, which produces the light yellow or orange color that we know. Martian sand in this area is rich in iron and magnesium, which makes it much darker. Looking at another section of the canyon floor, this time in a region called Noctis Labyrinthus, we find these patches of dunes, but everything has an odd green tint. This isn't just a funny angle of the sun, but it is thought that the ground is made of clay here. It looks like the sand dunes have filled ditches in the ground here. This is particularly evident when you see the little craters that are dotted around filled with sand. Moving on to another region in Noctis Labyrinthus, we find dark minerals on light coloured sand dunes. And even a small crater here. Until we get to this curious looking oddity. What we are looking at here, just to help you visualize it, is a mesa. A raised bit of land with a flat top. This mesa is only small, at 400 meters wide, but quite a few are found at the bottom of Noctis Labyrinthus. Just to show how varied the landscape around here can be, have a look at this beautiful view. You'll notice more clay around here, but you also have these much brighter patches of ground. This is thought to be hydrated material, or material that contains water. To the west of this image are some old volcanoes, which during their more active days could have melted the ice found at the bottom of this trough, which then sunk into the ground. Now, this amazing image, found in Meles Chasma, gives a breathtaking example of folding on the surface of Mars. Usually this happens deep underground by high heat and pressure, so why is it apparent here? A possibility is that these folded deposits were soft and deformable near the surface, such as wet or icy sediments, and the wind erosion has exposed it. It does remind me somewhat of a cliff or a rock cross-section. It's very beautiful. Okay, last one for today. I wanted to show you this small mountain range for no other reason than it is spectacular up close. The shadows certainly give a sense of how towering the mountains are. elevated very sharply above the rest of the canyon floor. That is fantastic. NASA's Mars Reconnaissance Orbiter has been imaging the surface of Mars for over 10 years now, with its powerful high-rise camera. 10 years of taking photos every day means that its catalogue is huge, and we can pick out pretty much any part of Mars that we want to have a closer look at. Today, I thought it would be really interesting to investigate the sand dunes on Mars and see how they compare to the wonderful sand dunes we have on Earth. You may have already seen imagery of the Sahara Desert, with dunes hundreds of meters tall, or the Namib Desert with rolling sand dunes as far as the eye can see. Did you know though that there are 5 different types of sand dunes, and that Mars has a type of dune Earth doesn't have? And also, what are the biggest dunes on Mars? The most common type of sand dune on Earth is the crescent or the Barkhan sand dune. While not always as distinctive as these dunes in this image, they are plentiful and found in most sand deserts. They are defined by this kind of crescent shape with arms, and they are usually wider than they are long, like you can see here. They form like this because in these places there is only one dominant wind direction. They have a shallow slope on one side that faces the wind and a slip face on the other side. They are a type of transverse dune, as they move gradually over time as the wind blows, whipping sand from the front, over the top and down the slip face. When many of them merge, they can create an almost wave of sand, smooth on the side facing the wind, with a slip face away from the wind, moving gradually over time with the wind's direction. They are also in plentiful supply on Mars. All of the ones I'm about to show you can be found at the base of various large craters. Going to this old crater near Mars's equator, Barkhan dunes can be seen lumped together somewhat here in this plane. This happens when there is a plentiful amount of sand and the dunes merge together into a big lumpy transverse dune. But individual dunes are really evident a bit higher up, where the sand is contrasted against the bedrock. Here are some more found in Arkhangelski crater. When there is a smaller amount of sand, the dunes tend to stay separate, which looks really peculiar from above. These dunes do move, although very slowly. Here's a couple of examples of dunes on Mars, moving slowly over the course of 2 to 3 years. Scientists originally thought that sand dunes would stay pretty motionless on Mars, as sand dunes require wind to move them, and Mars only has about 1% of the atmospheric pressure at the surface compared to Earth, whose winds can easily move sand. We knew the wind on Mars could pick up tiny dust particles, but it would require extremely strong winds to move sand. This could be helped though by the fact that sand on Mars is not exactly the same as Earth sand. In my Opportunity video, I mentioned that the sand particles Opportunity analysed were far smaller than what we're used to on Earth, which may aid the movement of these dunes. But what happens if the wind is bidirectional? Going back to Earth, a beautiful type of dune which can easily be seen all the way from the International Space Station is the longitudinal or Sif dune. Sif is the Arabic word for sword, which describes these dunes nicely as they are long and narrow. These linear dunes can be hundreds of kilometers long and are often found in parallel sets, separated by gravel or rocky corridors. These occur where wind directions can flip over, meaning that these ridges have a slip face on either side of the dune, making them appear quite sharp. Sif dunes also appear on Mars, and in my opinion, the most beautiful example of it can be found here. Again found at the bottom of a crater, these dunes look remarkably similar to each other, including this dusty band found on each one. Although we're not totally sure how they form, One leading theory is that they are the result of wind directions changing around Barkhan dunes. In this image, some Barkhan dunes seem to be mid-process of forming into Seif dunes. It's a really pretty image that seemingly tells a story. To our right here, we have a mesa being eroded, feeding sand into the valley below. Then you have these beautiful examples of Barkhan dunes, which show the step-by-step process of becoming Seif dunes. Another spectacular example of this, a bit further into the process, can be found here. The contrasts of the different materials in the image are stunning. And the dark sections are the sand dunes merging together. The third type of dune is the dome dune. Typically, these are not very big on Earth, usually only a few feet high. They have no slip face, they are smooth all over, hence the name. They are quite rare, and usually found in and around other types of dunes. And yes, these are also found on Mars. Here's a field full of domes, a few of which can be seen starting to cross over into Barkhan dunes. And in this impressive expanse of dunes, and I really do mean an expanse as these dunes continue on way beyond this image. You have wobbly lines of dunes with domes on the end of them. These domes seem to be much bigger here than they are on Earth. The domes here tens of meters across. This field is indicative of a change in wind direction, as the lines are nowhere near as straight as in some of these previous images. The fourth type of dune is a parabolic dune, which is the opposite of a Barkhan dune, meaning the slip face is on the other side compared to a Barkhan dune. These occur near coastal regions and form the way they do because something, often vegetation, anchors the arms of the dune in place. Lack of vegetation on Mars means it's a bit tricky to find parabolic dunes. The closest thing I found is this beautiful image, a dune wrapped around a large mound in the middle. The dune is clearly moving from left to right in this image, and you can even see the shadow of the slip face just by here on this side. The existence of this dune is heavily influenced by the size and shape of this mound, funneling wind along its walls. The fifth and last type of dune is the biggest type, the star dune. This is a dune where wind direction changes frequently, meaning the dunes in this region have 3 or more arms and are often stationary, just building up over time. This impressive image is the Sahara Desert as seen from the ISS, and it is full of star dunes. The scale of these dunes truly is impressive. Zooming in, you'll realize that these dots are people. And of course we have star dunes on Mars. Some are small, a collection of dunes merged together, but others are massive, like these found in Russell Crater, which reach far beyond this image. As this image is found nearer the poles, carbon dioxide ice can form on these dunes. During the Martian spring, the carbon dioxide sublimates, which dislodges loose material, leaving these streaks. Moving to another image, again near Mars's pole, we find one of the most beautiful images of Mars I have ever seen. This image was taken just as the sun was either rising or setting, meaning a lot of the image is shadows cast by dunes. I love this as it provides a sense of depth to the image. These again are big star dunes, with their individual arms reaching out for kilometers. There's one last thing I want to talk about the dunes of Mars. Have you ever been to the beach and seen sand ripples like these? These are actually a type of transverse dune, forming perpendicular to the direction of the water waves as they flow over the sand.
much like larger scale transverse dunes caused by the wind. Mars has these ripples too, but they are much, much bigger than what you would find on Earth, with a meter or two between the ripples. This size makes it difficult to see from space, but luckily we have another rover on hand, Curiosity, seen here in this image, to take this remarkable photo of them. Scientists didn't even know this type of dune existed, and it is a fitting reminder that although Mars may appear quite familiar to us, it is still a world full of secrets and unexplored facts, and there is still so much we can learn from it. Mars is littered with craters. Although Mars has an atmosphere, this atmosphere is very thin, meaning even small meteors manage to impact the surface before they burn up. The high-rise camera on board NASA's Mars Reconnaissance Orbiter has been able to image a lot of these craters in exquisite detail, meaning we can examine craters on another planet like never before. I'm Alex McColgan, and you're watching Astrum, and together we will look at some of Mars's most interesting craters, and I'll explain what it is you are looking at. We will start small. Here is a very small and very fresh crater that likely formed sometime between 2006 and 2008. New craters have some very distinct characteristics, specifically defined crater walls and evidence of fresh ejecta. Although this crater is just a few meters across, you can see the ejecta spread out over hundreds of meters. But this is over a flat surface. What if a meteor hits a slope? Well, that's exactly what happened here. The dust on Mars is extremely fine, meaning it can move quite easily. You can see the recent impact crater on this slope here, which caused an avalanche of dust down the slope. The area around the avalanche looks fuzzy because ejecta also spread out around the impact site. The dust is clearly precariously balanced, as there have even been smaller avalanches seen a little bit higher up. So if an impact caused this avalanche, what caused it in these large craters? What you are looking at here is slope streak formation, one of the few active geological processes on Mars that we know of. We don't exactly know why these streaks are formed, but the leading theory is that due to the tiny size of Mars's dust particles, the smallest trigger, like a gust of wind, can make the dust tumble and act like a fluid, like in a snow avalanche on Earth. The darker streaks are the youngest, the whiter streaks are older, the brightening caused by dust settling on them over time. It is quite the beautiful sight. Let's move on to a particularly flat area of Mars. This area is quite boring and featureless, but zooming out a bit, we come across this big, kilometer-wide crater, which seems to have a scar on one of its walls. This is actually caused by lava flowing down from the lowest point in the crater wall. The lava coming from a nearby volcano that has repeatedly covered this area in lava from its eruptions. That's why the surrounding area is quite featureless. This used to be a large lava plain back when Mars was more geologically active. That makes the surrounding area here the youngest surface on Mars. I can only imagine what this area once looked like. The game "The Floor is Lava" would be quite apt. Let's have a look at another crater heavily influenced by lava. This is Elysium Planitia, the second largest lava plain on Mars. This 3D view, acquired from a stereo pair of images, shows the basin of this crater is very flat. This is again due to lava flowing and filling the area from this vent found in the center of the crater. This is an old, inactive vent now, meaning the surface hasn't been renewed for some time. evidenced by the many craters dotted around the basin floor. There's another really curious crater I want to have a closer look at. This bizarre crater is found within the big Schiaparelli crater, and it kind of looks like a giant bullseye. We don't really know why it's formed like this, although it could be due to there being sedimentary layers in the bedrock that have been eroded smooth, or it could be that this is actually a flat surface, which just appears concave because the crater has been filled up by sedimentary deposits over time, meaning the innermost layer would also be the youngest. We don't have a stereo view of this crater, so we can't tell either way right now. What about craters that haven't been filled up by one thing or another? This is Pallica crater, a several kilometer wide crater that has also had the 3D treatment. This crater is pretty deep, stretching several hundred meters down from the rim. And along the crater wall you will notice what looks to be old water channels flowing down the bank. While liquid water can't exist on the surface of Mars, it is theorized that water could still flow under Mars's surface. Salty water that flows out of the ground could make its way down a steep slope like this for a little while before it evaporates. On a different crater, this flowing has been observed. Notice the differences over the years. Although we haven't confirmed this process is due to water yet, even if it is the leading theory, it could still just be fine dust that flows down the slope. Let's have a look now at a very old and deep crater. At first glance, you can see inflow channels going into the crater, and that it was once even deeper than this, but it has since been filled somewhat by sand dunes. Zooming in, we can see the sedimentary layers near the crater walls. Had this crater not been filled in by sand, perhaps it would resemble the previous crater we looked at in Schiaparelli. Somehow this crater's age just makes it look even more impressive. For the last crater we'll look at today, we'll have a look at another 3D view. This unnamed 15-kilometer wide crater is found in the Domani region, and seeing it from this angle is quite the sight to behold. Going over the crater walls, you'll notice this crater has 2 tiers of walls, and some peaks in the center. This is due to the size of the crater. Smaller, simple craters tend to have smooth walls all the way down to the basin. Larger ones have tiered walls, with uplift at the center. They are known as complex craters. Usually complex craters would be too big to fit in a high-rise image, but this is a combination of several images, which gives us an unprecedented view of such a large Martian crater. Coming closer to the crater walls, you'll again notice these water channels coming down the side. You'll notice the smooth appearance of the terrain, which implies dust has had a lot of time to settle here. So, there you have it, some of the most interesting craters on Mars. There are a lot more that I could have talked about, but sadly they will have to wait for another time. Thanks for watching. I was honestly blown away by the numbers of you that signed up to the Patreon. Like I said in the replies to your DMs on Patreon, everyone here at the Astrum team is so grateful to have such an amazing community. If you haven't joined the Patreon party yet, we're still on our long-term 1,000 patron member drive, so you can go to the link in the pinned comment to become a part of that effort. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Meanwhile, click the link to this playlist for more Astrum content. I'll see you next time.